Hello, my name is Victory, and in this course, we'll be looking at Linux for DevOps engineers. Now, most of the question I get when people reached out to me is, "Oh, I want to be a DevOps engineer. Tell me the tools and to learn." Right? What I always advise them is, I'm going to tell you the first thing you need to learn, and it's not a tool. Right? Now, people believe DevOps engineering is about tooling, right? But it's not about tooling. It's about processes and lots more. But when they come and like, oh, I want to learn, I want to be a DevOps engineer, what should I learn first? I'll say the fundamental thing you need to learn, not just a DevOps engineer, but as a technical person, is to learn the Linux, right? The Linux operating system or the Unix operating system. And there is a reason for that. The reason being that majority of production servers you will work with as a DevOps engineer runs on Linux. It is just the truth. Then, as a DevOps engineer, you'll be working a lot with Kubernetes or containerization. It all had its foundations on Linux. Is it automation thinking? Linux, right? Troubleshooting and operations, you need to understand Linux. So that's why I always tell them Linux is the operating system, or Unix. I'm going to be interchanging Linux and Unix, right? Is the fundamental operating system that we use in production. Now, let me show you a shocking statistics, right? Okay, so in production, right? We if we take like how would I put it now? In production, if you take the when we check the website that we actually know the operating system that they are running on the internet, do you know that 91% of it actually run on a Unix based operating system? Why just about 9% run on Windows, right? And also, when we talk about a million websites, that's the top 1 million website, guess what? 81% of them run on Unix, right? So it is very key. Like, imagine the likelihood that when you, as a DevOps engineer, are going to be working on a production system, be it a freelancing, working with someone, or even working on your own system, the percentage that you are going to encounter a Unix Linux based operating system, right, is actually 91% or 81%. That alone should give you the reason why this is a core aspect. And if you miss it, this is the fundamental of you being a DevOps engineer. And if you missed it, you will struggle, right? So that is why you really need to embrace it. As a DevOps engineer, also, you will encounter containerization, you will encounter Kubernetes, you of course you work with servers and operation. All of these I just said all run, right, all run in the Linux. So it's like you understand the ABCD and how to put words together to form anything. With that, any reading you want to read is like you've settled the fundamental. But imagine you don't understand fundamentals, you cannot read ABCD, you don't even know how the combination of ABCD form a word, and you are just jumping into wanting to learn a word. You might learn by rote memorization, but when some challenges come, when you encounter some challenges, you will need to go back to the fundamentals. That's actually how Linux is. You need to understand the fundamentals. So it is a no-brainer. Containerization, because next thing, oh, what should I learn? Some people say, should I go and learn Docker? Should I learn Kubernetes? I would not advise you to learn Docker, Kubernetes, or anything if you don't understand the Linux operating system, right? So why is that? Number one, we use it for automation. As a DevOps engineer, most of the work we do is automation. We use it for automation. Linux allows you the manipulation to be able to manipulate files, to be able to do filtration, transformation, scheduling, and all of that. So what I'll be focusing on is take bits and bits and bits, like I said, learning ABCD, taking these bits, right, putting them together to form a word, to form little script, and you're actually able to run the script, and you iterate, right, you repeat, you iterate, and you're actually able to get something out at the end of it. Why is that? As a DevOps engineer, you might be working in which is the likelihood that you are working with CI/CD pipelines is very high. You need automation in this process, right? You work with infrastructure, you need Linux in this. Of course, platform engineering, which is the int now, you need the basis of operating systems, right? So Linux make engineers think in interfaces, right? State, output, recovery paths. Linux thinking it is, right? You need this knowledge to be able to advance your DevOps career, right? And if you're already a DevOps engineer and you are saying, "Boy, I'm a DevOps engineer, I don't know Linux," it's like I've never seen anybody say that, but it will catch up with time. So it's always better to go back to the basis and actually get the basis right, rather than just guessing command and asking for command whenever you need to do some debugging or perform some operations, right? Then another thing, Linux shorten the paths from incident to insight. One thing I love about it is that in terms of processes and services, networking, files and permission, right, packagings, everything, we are actually Linux has each of these commands, and the ability for you to be able to put them together, to be able to detect, to inspect, to fix, and to write a code and to reiterate, repeat this process, it's actually what makes you a very good engineer. So in a nutshell, what we are going to be covering in this course, we're actually going to be looking at the path we are going to take, right? For example, we are going to be looking at how to navigate the file system, how to understand users and permissions, right? How to read processes and all of that, network, right? And how to also write small bash scripts, right? So that at the end, with this little knowledge, you're actually able to put them together to produce something that is production grade, repeatable, and you are actually able to iterate. So what am I saying? Linux is not just another topic in DevOps. Linux is not a tool. You know, when you come, what tool should I learn? Should I learn Linux? Linux is not a tool. It is the environment where DevOps engineering thinking becomes practical. It is the environment we work on every day. So one of the things I will be doing at the beginning of this course is, when I understand most time, especially if you're a new beginner, to be able to relate with what we are doing. So if you've never really worked in a terminal before and just bring up a terminal and just say, oh, this how you do this how you do this, that confusion will be there. So one of the things I will do, I will initially at this first stage, I will bring up a GUI. This is how you do it in GUI. This thing you do in a GUI, like for example a Windows, I'll be using a Windows. It can be a Mac, it can be anything. This is how you do it on a graphical user interface environment. But now this is how you do it in a terminal. It's no different. So that's one of the things I will do at the early stage, so that it's not totally abstract to you, but rather you're able to relate with it from known, which is your normal GUI system, to unknown until you feel comfortable. Then we can move down the E. So over time, I'll be bringing up the Windows terminal, a GUI terminal. It can be any terminal. I say terminal, a GUI interface to actually show you, oh, this is how we do the navigation, but this is how it is here, right? So it just makes you to actually have that proper understanding. With that being said, let us just head over to the terminal and actually work with Linux, work with this command, see this little command, and later on try to put these commands together, right, to be able to start forming little scripts that we'll actually use for automation process. Let's go to the terminal. So as you can see, I am currently in my Linux terminal, right? I've actually SSH in. Now the question is, I have a Windows. How do I get a Linux? Although it's not covered in this course. So for example, you have a Windows operating system, right? And you want to have a Linux on it. It's two ways. First off, right, you can just enable WSL, right? You enable WSL on your laptop. You can just Google it. You enable WSL, that's Windows subsystem for Linux, right? Then you install Ubuntu. When you do that, you are actually able to get the Ubuntu terminal comes up for you to use. It mustn't be Ubuntu, but we're using Ubuntu for this course so that you can follow along. So that's one part, but make sure that your system is good enough and allow virtualization. Although depend on the instruction you follow. Most time, if you enable virtualization and it's not working, you might need to enable it from your BIOS, right? From the BIOS of your laptop you are using, right? That's one way. Another thing I always advise my students is this, right? If you have old computers, you don't need to throw them away, right? For example, I understand as we upgrade our gadgets and all, there are some old computers lying around. You have a computer of 4 gig RAM and like, no, this is too old for me, I can't use this anymore, and you look for either to pawn it away or throw it away, right? You don't have to do that. Even if the screen is not working or what have you, you just need the CPU itself, like the process itself, to be working, right? If you have the process working, you can actually connect it to an external monitor, connect to external key. I don't care, maybe it's the key that is not working or whatever. connect them to external, format it, and actually install Ubuntu in it. It actually teaches you a lot during that process, right? So that you can add Ubuntu and you connect it to your home network. So if it's connected to your home network, you can now from your own primary laptop or your primary computer SSH into that server, and you are able to do a lot of operation on Linux too. That one really helps because most time if your system is not that, your primary system is not that good enough, enabling WSN and installing Ubuntu might also put a strain on it, right? So you can actually do that. Or you, and funny enough, you easily get those laptop that it's like they are, because they don't have that high spec and you cannot really upgrade them, people want to throw them away and all. Funny, in this tutorial that was one of such computer I used. I have a computer that I've not used for a long time. What did I do? I don't care about the whatever is not working. Is it working? Yes. I ran Ubuntu on it, connected it to my own network, and I have now SSH into that system now, and that's what I'm going to be using for the purpose of this course. Just try it out, right? This is not the age you throw away old laptops, especially now with open cloud, or you'll be able to have spare laptop to just run some things on. So that is what I'm going to be doing. Now the first thing we are going to be looking at in this course, right, is navigation. Definitely, you know, when you have a new system installed, you want to be able to navigate, to move around, especially navigate the file system. How do I go here? How do I go here? How do I go here? Right? The first thing we'll be looking at is navigation. Now, how do I go here? How do I go here? So for example, I'm going to bring up a window GUI for you to understand what I mean. So here is a window GUI. Yeah? If I want to go to documents, for example, or download, it's simple. You know, you just come here, which one is download, and you click on download, and you're actually able to see your downloads, right? Then for example, if I want to work on, let me say, pictures, I can come here. So this is navigation, right? You can just click on it and you see what you want. In Linux, especially in the terminal, first of the thing you want to know, where am I even currently on? How do you know where you are currently on? It's simple. PWD will show you your present working directory, meaning which part I am. You see, I could navigate to, if I know I'm in download, I can from download navigate to pictures. If I know I'm in pictures, I can go to document, right? When you do PWD, it actually showed you the part you are currently. So before you do anything, it's always good to understand where am I. So for example, you want to create a file, you want to create a folder, right? If you do that, where am I? PWD, which, where am I currently? You know, you can actually see it. Where am I currently? You'll be able to see, oh, this is the part you are in. Currently, I'm in the home get techie directory, right? So that is how to actually check where you are currently. Another thing you want to do is to be able to list the files. What are the things that are currently on this part? So by doing ls, right, you are actually listing what are the folders on this part. What that simply means is that if I come back again to the window UI, in this case you don't have to list, because by default when you go to that particular directory, right, it actually lists whatever is on that directory for you. You get what I mean? So you don't have to like, oh, how do I list in GUI? But because this is not GUI, you have to actually list to see what is there. Currently, I only have just one folder on my path. You see, when I listed it, I only have one folder on my path. Now, let me quickly introduce. There's what we call flag in Linux, right? Whereby what I mean by flag is you have a command, but you can actually add some extra property to make the command do more. Right. For example, ls will list the file part I have, but there are some other things I want to do, right? So let me give you an example. Let me go back to Windows again, right? I have, you can see this is my Windows terminal. This is what I can see. But there are sometimes I want to see some hidden files, and really they are always hidden files, right? If I want to see some hidden files, you see, I'll click on this place. I'll now click on show, right? I'll now say, oh, I want hidden files to show. Are you seeing something like this now? I want hidden file, and if I have hidden file, it will show. But when I use ls command, it's just going to show what is just there. But how do I show the hidden file? It's simple. I'll just use what we call a flag by doing ls-a. When you see a dash, meaning that's a flag extra to make the command do more, right? So if I do this, now you can see, in as much that when I list, it just shows just one small file, but immediately I added the flag, you can see it has a lot of other things that it shows, a lot of other hidden files that are not there, but when you want to see the hidden files, you can see them, right? Another one you can also do, so I'm going to clear this. To clear, just write say clear, and you're able to clear the screen. Why do you clear the screen? Most time you have a lot of command, a lot of cluster. You can just clear the screen to make it clear, right? Then looking at ls again, like I say, if I list ls, it's just going to show one thing. But what if, right, what if I want to list it in a long form to be able to see more property of this file? I will do that. I will add the flag again, ls. In this case, what's my flag? Dash l. When I do this, you can see it gives me more. It's tell me, oh, it's a directory. It is only the owner that has read write permission. I will explain all of that to you later. But this is the user, the group, and all of that, the date it was created. So you can see, right? So these are what flag actually does. So I'm going to clear this again. Now the question is, if I want to open, if I check, I have one directory, snap. If I want to go into the snap directory and see what is there, how do I navigate that? What I'm simply saying is that if I come back here to Windows, no, it's easy. Oh, in Windows I have, let me say, I have a folder, I have a file. How do I navigate into the file? How do I check inside what is on that file, right? Like if I click on it, what do I see? That's what we want to also do here. Like if I open, how do I even go into this snap to see what is there? It's simple. It's either I list snap like this by saying ls, and I want to list what is on here by saying ls snap, and I'm actually able to see that, oh, inside the snap there is what we call tree, right? And if I want to also list what is in tree, I can just say ls tree, right? And I'm actually able to see what is in tree. In tree, you see I have three things in it. 54 common, current, right? If I want to see what is on that 54, so it just go down the rabbit hole. It's like you are just keep clicking and clicking and clicking. I can see there's really nothing there. When it returns nothing, your command executed properly, but there's actually nothing in it, right? So that's actually how you list. Another thing, instead of just listing, I can want to go, just like you click on inside a file to go into the file, right? If I want to go into, right, let me list where I am again. If I want to go into snap, how do I go into snap? It's simple. I just say cd snap, right? If I do cd snap, currently you can see I'm actually inside snap. By so doing, when I do ls again, I'm listing what is in snap, which is tree, right? I can still go inside tree again, right? If I go inside tree again, right, if I do ls tree, I'm actually listing the things that are inside tree. But currently this is the part I am in. How do I go back one part? Like to go back using the, what I mean is, for example, let me come back here again. So for example, you have this and you want to go back, right? Like using this arrow to navigate, like front, to move one directory in or to move one directory out, right? So in that case, what I will do, I'll just do cd. Remember, you use cd to enter, but you use cd dot dot to move out one directory, right? If I do that again, I move out the other directory. If I want to go to my root folder, I just use cd the tilde sign, and I'm able to move to my root directory, right? So that is just that. When you see the tilde, like what I mean, if I do cd then do my tilde, it will move me to the root directory. If I do again present working directory, I'll be able to know I'm now at the root directory. If you use this particular command anywhere, it will take you back to your root directory. Is that okay? Okay. So now, that being said, we've looked at how we can list file in a directory, how we can actually use flagging, right? How we can also move forward in a directory using cd, and how we can actually move back. Another thing is that most time we want to actually see, in as much that we say this interface is pure, it's not GUI, it's pure terminal. There are sometimes there are still some little how will I put it now, little things that actually give us that GUI experience, right? For example, if I come and say tree, if I do tree, it will actually give me, oh, I have a folder called snap, or a directory called snap. Inside the directory snap, I have what we call a tree. Inside the tree, I have these three files, right? So just like that. Now if you try this tree and you get an error, it's possible you've not installed it, right? Is a package that you install. If you install it, you'll be able to get this, right? So this actually give you that general overview of, oh, this is the hierarchy, this is how these files and folders are being structured, right? So that's actually how you navigate in Linux. The next thing we'll be looking at is actually files and directory. So I'm going to clear this screen again, and we are going to be looking at what? Files and directory. What do I mean by files and directory? So if I go back to Windows again, so for example, you are in a Windows, right? And I say, oh, I want you to create a folder. What you just have to do is to come here, right click, right? On a GUI, remember it's not only Windows, you can do this in any GUI operating system. I'll click on folder, and I can call this folder, let me say tutorial, right? If I call this folder tutorial, this is how I create a folder. Now if I say inside the tutorial folder, I want you to create a file called file.txt, you open the tutorial folder, you come inside, you right click, and you come to new again. But instead of folder this time around, you go to file. It can be any of the file that you want, right? I'm just going to click what we call a text document, and in this case I'm just going to call it what? File dot what? Txt. Can you see I've created a folder, I've created a file inside, right? So, but how do we do that, right? And if I want to go back, remember, it's like I cd into it. If I want to go back, use my back arrow, I go back to tutorial, and I can still come create another test file here, right? I'll come here, create another test file, and I call it file 2, right, dot txt, right? We are all, this one is very familiar to us, but how do you do that here, right? How do you do that here? To create a file here, right, I'm going to do ls to list. We don't have anything apart from snap, right? To create a file here, you use the command touch, right? touch, right? Touch the name of the file you want to create. In our own case, file.txt. Now it must not be tsv. It's because I'm creating a test file, that's why I'm using tst. It can be file.md if I'm creating a markdown file. It can be file.ps1 if I'm creating a PowerShell file. It can be file.sh. It can be any extension that you are creating, right? I've created it. Another thing you should know in Linux, if it does not return anything, except maybe you are running a script and you told the script that if I do this, return this. But most time when you write a command and you press enter and you don't see anything, it means the command works. If the command fails, it's going to tell you it fails, right? So if you don't get anything returned back, take it in good faith that it actually works, right? Okay, so let's go along. We've created a file. Remember to check if that file is there, to list. If we do ls again, what do we do? Now we have our file.txt there, right? How do we create a folder? Let's say we want to create a folder, call my folder. How do you create a folder? It's simple. You don't use touch to create a folder. You use what we call mk, like make dir, make directory, mk dir, the name of the directory you want. In this case, let's say we want my folder, right? Nothing. ls, what do we have? We have my folder, we have test.txt. That is how you make a folder. Now another trick I want to show you, there are sometimes you want to make a folder inside the folder inside the folder. So for example, I want to make folder 0 inside folder 1, inside folder 2, inside folder 3. Should I need to create the first folder, create the second folder, then look for how to move them around? I can as well just do this. Remember to make a folder is what? mkdir, right? Then I'm going to say I want this to be a parent directory -p. And what am I going to do? I want it to be what? My folder 3 slash my folder 2, right? My what? My folder what? 1. When I do this, I'm going to have folder 1 inside folder 2 and folder 2 inside the folder 3. Now remember this flag. Remember I explained to you, flag is when you want to make it do more. Here we don't have flag, we want to make it do more. So with this flag, if I press enter, it's actually going to create that structure. Without this flag, it's going to throw an error because it's assuming that the parent directory already exists and I'm only creating this folder, right? So I'm going to press this enter now, and now if we do what again, you know it's ls, right? We can now see we have my folder 3, but inside my folder 3, if we actually list what is in my folder 3, if we say ls my right, if we do ls my folder 3, right, and we list what is there, we'll see my folder 2. And if we leave ls what is in my folder 3 and my folder 2, we are going to see what? my folder 1. Do you get it now? Or of course, this is where tree helps. Tree show you how it goes. So you can see tree show you we have my folder 3. Inside my folder 3, we have my folder 2, we have my folder 1. Are you seeing now? So this is actually the beauty of what tree shows to you. I hope you understand that. Then the next question is, how do we now we've created a file, we've created a directory, but what if we want to copy a file? So let's assume I want to copy this test.txt into my folder. How do I do that? Copy. So let's go back to Windows so that you see what I'm telling you. You see, I have this test file 2.txt. I want to copy it inside here. There are two ways. If I want to copy it inside here, what will I do? I will come here, right click on this guy, right click on it, say copy. Then I will come here, right click, and I will do what? I will paste it here, right? If I do this, right, now if I go inside, I'll still have this file here. Remember, I only copied, I didn't move it. If I go here, you can see I now have the file here. That is how we copy, right? But what assuming I want to move it, if I delete this file that I copy, come back here and delete it, right? Let's assume I want to move it. Remember, go one folder back. If I want to move that file, all I just have to do is to drag it and move it toward the tutorial folder, right? Now when I move it, it's no longer here because it is now in where the tutorial folder, right? So you can see that there's a difference between copy and moving, even on the GUI. That's what we are going to be demonstrating here. So for example, if I want to copy file.txt into my folder, how do I go about it? All I just have to do is to what? Copy cp. What am I copying? I'm copying file.txt, and where am I putting it? My folder. Do we get it now? So with this, if I do enter, remember I'm copying. When I press enter, if I now check my folder by doing tree again, right? If we do tree, you now see that inside my folder now, I now have what we call what? File.txt. Do we get that now? But what if I don't want to copy file.txt? So to copy, you use the term cp, copy, right? Copy the name of the file you want to copy, the destination, right? What if I don't want to copy this file, but I want to move this file? So I want to move this file. I want to move it in, instead of putting it in my folder, I want to move this file down to my folder 1. For me to move it down to my folder 1, I have to reference this part properly. So what do? I will come, instead of using cp, I'm going to use what? Mv. Mv means what? To move. And what am I moving? I'm moving file.txt, right? I'm moving file.txt, but where am I moving it to? I'm first of all moving it to my folder 3, right? Slash what? My folder 2, remember? Slash what? My folder 1, right? That is the part I want to what? Move it to. Then I press enter, right? Now you know that if I do tree again, if I do tree, this file.txt is no longer there because I didn't copy it, I moved it, right? But it will now appear under my folder 1 because that is the part we actually reference, right? So if I come here again and tree, what do I get? You can see it's no longer there, but if you check under my folder.txt1, is now there. Do you get what I mean? So actually that is how you move a file from one folder and one part to another. It can be moving from different directory altogether, right? Which we move from. So you can move a file, right? Another thing is, how do you delete a file? So let's quickly create another file. And let me just create another file. Say file4.txt, right? Of course, remember to create a file, what do you use? You use touch, right? File4.txt, right? So if we do ls again, now we have file4.txt. Now, how do you delete file4.txt? You use the command rom. Rom means remove. What am I removing? File what? 4.txt, right? Press enter and it's gone. If I come again, list it, file 4 is no longer there because I have removed it. Now the question is, if you use rom to remove file4.txt, how do you remove a folder? Let's assume I want to remove this folder. How do I remove this folder? You guess it, right? rom what? My folder, right? But with this work, the answer is no. If I say enter, it's going to tell me this is a directory. Let's see. You see, we cannot remove my folder because it is a directory, right? It doesn't care if anything is in it or not, but it's a directory, so you can't just really use rm to remove it. So you can actually use something like this. Either you remove rm dir, right? Fail to remove my folder because the directory is not what empty. You use rm, that's remove directory, most time if it is empty. Or you can still use rm, right? You can use rm. So we are going to use rm, but you are going to add a flag recurse, right? If you do this recurse, it's going to actually remove that folder. Now you can either use this or you use arrow, the flag arrow f. But the challenge with this flag is a very powerful. That f means force. It's going to force remove it. So most time you might not want to do that, right? Because if there are some protected file, it's going to force and remove it anyway. So you have to be careful. This command is a very dangerous command, right? So we're just going to use arrow m, remove recurse, then we're going to remove the my folder. And when we do that, now it's gone. Remember, when you don't get any feedback, your command works, right? So if I come here and do ls, you see my folder is gone, right? Now the truth is, unlike the GUI or the GUI, the normal computer you are used to that you can click here and there, most time when you delete a file, you actually go to recycle bin and find it, right? Although it doesn't happen with servers. This is a server, you rarely can go back to recycle bin. I've not been able to go to recycle bin. So be careful what you delete, especially when you are working with servers, right? You should be very careful what you delete. Although of course it's possible, there's a way you can now look for how to recall it back, but most time when you delete it, it's actually gone, right? So be careful what you delete, and that's why I say you should be very careful of using the flag arrow f, because it's actually very powerful. It's forcefully deletes that file, right? Now another question I want to quickly write. So is it possible for us to remove a particular file in a directory? Remember, when we do tree again, we actually have test.txt in this part. Is it possible for us to actually remove test.txt? Can we just say arrow m, right? Then what are we removing? We'll go to my folder, right? 3, then we'll go to my folder 2, then we'll go to my folder 1, right? And we do what? File.txt and actually remove it. Yes, it is possible. It's not going to remove the folders, but if we do 3 again, you are not going to see, you see this file.txt we have is you've removed it, so we are not going to see it again. Can you see under my folder 1 is gone? So that's actually how you delete folder, right? Now I want to create another folder. I'm going to create another folder. I just want you to understand folder manipulation. So I'm going to have, remember, to create a folder, you use what? mk what dir, right? I'm going to create another folder and I'm going to call it my folder 0, right? Now I've created a folder called my folder 0, right? If you see my folder 0 is here. I want to move this my folder 0, right? I want to move it to, so after I have my folder 1, I want to move it inside my folder 1. How do I move it? You know the word, right? How do we say we remove something? We use what? mv. You can use mv to move or to actually rename, right? You can use mv. First of all, let's rename this my folder 0 to my folder 01, right? So if I say mv my folder, right, my folder 0, and what did I want to call it? And I want to call it my folder, right, 01. Are we seeing it now? So if I do this, I've actually now changed this my folder 0 to my folder 01. So if I do ls again to list it, guess what I'm going to see? It's now going to be my folder 01 rather than my folder 0. So you can actually use this command to move a file to a particular part or to rename a file or a folder, right? I hope you get that. You can also do that for a file, for any file. Just use mv to rename it. But if I want to move this folder, it's still the same pattern, right? mv, but in this case, my folder what? My folder 0 what? 1, right? So my folder 01, but in this case, I'm moving it to where? My folder 3, right? My folder 3, right? Then we have my folder 2, then we have my folder 1, right? We want to put it inside my folder 1. If we do that, we have moved it. If we do ls, you can see it's no longer there again. But if we do tree, we are going to see that it's now under what? My folder 1, my folder 01. So that's actually how you manipulate file, you delete directory, right? You move directory, you delete file, and you copy file. So we've looked at copy, we've looked at all of that, right? So those are just normal directory. The next point we are going to be going through is how do you view content of a file. What I mean is this, right? Let me quickly show you. Coming back here, right? Let's go back to the tutorial folder, right? So we have the parts pics, right? Inside pit we have a folder called tutorial, right? How do you actually like view this content? For example, I'm going to come here and I'm going to open this file up, right? Okay, cannot find the part specified. Okay, so I'm going to open that particular folder up, right? File.txt. Oh, did I call it .txt.txt? Let me see. Okay, fine. I'm going to open it up and I'm going to write something in it, right? I say this is me, right? Writing to a file to show how easy right? So write with a GUI window, right? Just something random, right? And how do you save? Simple, Control X, right? Or Command S, wherever you are, right? And I close that file and I'm done. Like I close it and I'm done writing into this file. And if I want to read what is on this file again, I double click on it and bring out what is on this file. Easy, right? How do you do this same thing on a Linux terminal? Because we write files a lot, we also read files a lot. So first of all, let's clear this so that we have a cleaner screen. Where are we? What do we have? Do we have any test file? So we'll do tree again. So far we just have folders, we don't have file. So let's just create a file. Let me say in folder 2, right? How do you create a file in folder 2? How do you create a file? Remember, you use what? Touch. Good. You use touch, then the name of the folder. So let's call it file.txt again, right? But in this case, where do we want it to go? We want it in my folder 3 slash what? We will say we want it in my folder what? 2, right? This is the part we want to create, file.txt. Then we press enter, right? If you do 3 again, you are going to see that it's actually let me see. Oh, sorry, let me see. Where are we again? So we created a file.txt in my folder 3, my folder 2. Oh, why is it not in my folder 2? Yeah, file.txt, my folder 3, my folder 2. Then if we do ls, okay, we have the file.txt here. Then if we do 3, oh, it should be in my folder my folder 3 slash my folder 2, right? Okay, so well, if it's not on that part, we can actually create it, but we can actually move it. But let me see, what did we miss here? File.txt and the parts, my folder 3, my folder 2, right? Don't I have my folder 3, my folder 2, my folder 1? Okay, you know what, I'm just going to move it, right? So I'm going to do, remember to move it, mview file.txt, and we want it in my folder 3, my folder 2. Let's see if we can move it there now. So if we do 3 again, it should now be in that part, right? You can see it's on that part now. So now, remember, now that we have it, the question is, how do we write to it? First of all, how do we read the content in file.txt, right? So we do cat is in my folder 1, my folder 2, right? And is what? File dot what? Oh, file.txt, right? So when we did cat, we didn't really get any response. Nothing came, like nothing came, because there's nothing in it. So instead of doing cat, we are going to be using we are going to be opening this file up and we are going to be writing into it. To open this file up, we have in Linux there are two major editors you can use, right? You can use Nano. Nano is very easy to use, but I'm going to show you how to use it too. You can use Nano or you can use Vim. So if I come and say Nano, Nano, in case you type it and it's not there, you can actually install it. Nano is very simple. Immediately you open up the GUI, guess what? It gives you the ability to start typing. So I can say this is a test file, right, that I am writing into because I love to write. Let's put something like this, just something simple, right? Now the question is, how do I save? Do I press Ctrl X here? No. Look at this command. If you check down here, or if you check the down, from down you'll be able to see all the possible command you can use, right? So what I'm going to do, I'm going to be exiting from this. No, you say X to exit, but if I do Ctrl X to exit, you say, hey, whoa, are you just going to leave? Are you not going to save? Press Y to save if you want to save, or N to say no. I'm just going to press Y to save, and after I've pressed Y, are you getting now? You say file name to write to. Is this the file name you want to write to? Once I press enter on my keyboard, it has actually written to that file. Now if I go and do cat again, I'm using my up arrow to bring the previous command. If I do cat again, I press enter. Now you can see it can now read it and say this is a text file that I'm writing into because I love to write, right? Now I told you I'm going to show you the two editor we have. I've shown you Nano. I want to open this same file again and write to it, right? So in that case, what I'm going to be doing, rather than Nano, I'm going to use Vim, VI. So I'm going to be writing to that part, to be editing that part again, right? So I'm just going to remove this cat and I'm going to have what we call VI, right? Vim. So I press enter. This is what we have before. Now in this editor, you cannot just start writing. It's not going to work. You have to first of all press I means insert, meaning you are telling the editor, I want to insert into this file. By pressing I, you will see that insert. Can you see the insert button? The insert word, meaning now is ready to start writing. So I'm just going to come here, press enter, and I'm going to say this time I am using the Vim editor to write more to this to write more to this file, and I hope it is really good. Now the question is, now that you finish writing, how do you save? For you to leave the insert mode in this Vim editor, you have to press what? The escape key, right? When you press the escape key, it's now ready. But how do you save? It's not even telling us anything. For you to save, you are going to press down your shift button and you are going to bring the column. You see this down here, can you see column? For you to save, you have to use W. W means to write, meaning I'm writing into this file, right? If you do that and you press enter, now you have saved whatever it is right there. And I can continue even writing again after save. All I just have to do is to do what? To just press insert again, right? I can now come, start again, and say, now that I have saved and now writing again, I need to save this as well, right? Just coming up with something random, right? It's on the insert mode. How do you leave insert mode again? Escape key on your keyboard, right? When you press the escape, now you are going to press what? Column again. W to write, but Q to quit, meaning save this file, write this file in, but quit this editor, right? And I press enter, it has written it. It has also what? Exited the editor. Now if I read what is in this folder now, you can see the first one we wrote. This time I'm using the Vim editor. Now that I've saved and now writing again, are you seeing it now? It actually saved them incrementally, and we are actually able to use cat to read them. Apart from using cat to read them, there are also other things that we can actually use. There are sometimes that the files are really much, to be honest with you, right? So you can actually use command like less. You might not see the impact or the effect here. Less actually gives you page by page view, like it gives you a page by page view, right? So you're able to see the first page, press enter to see the second page, and so on and so forth. And when you are done, press the q button means quit, right? So you are not seeing the beauty here because this is just a one page file, but there are times that you are reading log files as an engineer, and you have log file of how many pages, right? Or you are trying to read a readme file, or you are reading a configuration, going through a configuration file, and you want to navigate it page by page, right? So that's where you actually use less to move between page by page. Another one that you will use more is actually the head, right? What the head actually does, it gives you the first 10 line head, head, right? It gives you the first 10 line. Like I said, you won't see the beauty here because this file is not much, but imagine the file is much. It's a big log files of how many pages. If you use head gives you the first 10 line, right? Then what if you want to just see the end of the log file? You want to see the end of the file. You guess the right word to use, right? You are going to use what's the opposite of head? You are going to use tail. So if you do tail, it give you the last 10 lines, right? So head give you the first 10 line, tail give you the last 10 line. And there are sometimes also, so I'm going to clear this again. There are sometimes also when you are reading log files, right? You want to keep watching, like you want to leave the files, but you want the new things that are coming up. So you will use you can use tail, but you are going to add a flag to it. What flag are you going to add? You are going to say do the flag F, meaning you want to watch this, right? Like let me see, let me watch it. As the process or whatever it is that's writing to that file is writing, you are actually seeing the updated one. So now that I did tail, you can see it's like it's not just showing everything, it's waiting like to get to show me more things, right? But so imagine it's a log file, as the application is writing to it or a process is writing to it, it's actually showing me real time. So sometimes we use this flag a lot when you are actively debugging and you want to see what is happening. You are performing some actions and you're expecting to write some things to the file. You're actually seeing it real time as it's writing to that file, right? So are we good? Now that is here, if I just want to leave here, of course I'm just going to do Control C, right? If I do Control C, I'm able to leave there. Then another one we normally use, most time you want to know the line numbers, right? You want to know the line number. It's simple. I'll just come here, right? Don't mind me, I keep using the up arrow because I don't want to keep typing the part of the file again. So I can just do NL, right, which is the line number, to insert line number. So you can see, you remember this was about 3 paragraph. This was the first paragraph, second paragraph, third paragraph, right? So you can also the line number here beautifully showing, right? So that's actually how we view the content of a file. So the next thing we are going to be moving on, we are going to be moving on to permissions, right? So I'm going to clear this and I'm going to quickly share my Escali draw. I want to quickly explain permissions to you in the Escali draw, right? So that you will understand it. Then we'll move. You understand the numbering system. Then we'll move deeper into it, right? So now I've just brought up my Escali draw, right? There are 3 things you actually do to a file if you really look down into it, right? There are 3 things we do to a file. What are the things we do to a file? First, we read into a file, right? You can agree with me. Then we write into a file, or we execute a file, right? These are actually the 3 things we do. Now, what do I mean by we read into a file, we write into a file, or we execute into a file, right? Let me show you what I mean. So, for example, I'm going to bring back a GUI again for you to understand. So, if we so we have this GUI, right? So let's go back to the initial, right? At this point, what I'm doing, the fact that I'm able to navigate and see content, what I'm doing is that I'm actually reading these files. Can you see? I'm reading these files. If I can open this and see the content here, I can read this file, right? But beyond reading, if I can type into this file, this is me writing into this file, meaning I can write what into this file. Not only can I read the content, I can edit it, I can input into it. So at this point, I'm performing what we call what? A write operation, right? At this point, I'm performing a write operation on this file. Then the next one, when I can execute, imagine this is a script and I can run that script, right? If it's a PowerShell script and I can actually run it and I'm able to execute it, meaning I have that permission to be able to install something, to be able to run this. That one is what we call the execute permission. So those are the three permission we have, right? What are the three permissions? We have the read permission, we have what? The write permission, and we have what? The execute permission. So the read permission, in terms of number base, how do we know the number? So I'm going to do this. The read permission has what we call the value of 4. The write permission has what we call the value of what? 2. And what do you think the execute permission will be? You are right, the value of 1. So these are the value: read, write, execute. And how do we write them, or how do we see this pattern? You see something like this: read, write, execute. So this is what you see. If you see for a file and the person have access to read, write, and execute, it therefore means that what? The person actually what? Has the permission to read the file, to write the file, and to execute the file, right? So that being said, now there are also different kind of people we have. I'll touch on it for a little. We have users. For example, you are a user. Then we have group, right? Then of course we have what? Users or owners. Then we have what we call others, right? Owner, which is the owner of the file. Let me use the word owner, right? We have the owner of the file. Let me put it that way. The group and every other person, right? So when you create a file, you are the owner of that file. And if you are the owner of that file, depend on the permission you set, right? So if you have read write permission, we can say that you have what we call, if you add these numbers together, is a 7, right? So if you have read write permission as an owner, let me move this. If you have read write permission as an owner, we can say what? You have what we call a 7 on that file. Let me put it that way, 7. But what if it's a group? You want somebody to be able to read the content of the file, but you don't want them to be able to write the content of the file, but you want them to be able to execute the file. So in this case, their own permission is going to be read, right? We don't want them to write, but we want them to what? Execute. Can you see? You cannot have this permission. And at that point, what will be the value? Remember, read is 2, read is 4, but write is what? 2. At that point, is going write is 1, is going to be what? 5, right? You want to do the same thing for others. Or others, you just want them to be able to read, you don't want them to be able to execute. So they are going to have something like what? Read, no write, no execute, right? So in that case, you can say what? They have what? 4, right? Because they can only read. So at this point, if you have a file called file.txt, file.txt, right, with this permission I just show you on the owner, the group, and the this thing, we can now say that if you want to write those permission, you can have something like this. If you check the length, like you should check the full permission. You can have, if it's a file, it's going to have initial as this file or any other, but it's going to have, for the owner, it's going to have what we call read, write, execute, right? Then for the, so if for the owner is having read, write, execute, right? For the what's it called now, the group, we said we gave it a read. So the group is going to have a read, but it cannot write, but it can execute. Why for the, what was it called, for the others, we gave it also what? A write, a read, but it cannot write, cannot execute. So when you see something like this, this is actually how you read it, right? But if you want to give this file permission with this permission now in a numeric form, how do you give in a numeric form? Remember, when somebody have full access read write, it's what? It's a 7, right? That's the owner has a 7. Then remember, the group has what? Write and execute is a 5, right? Why the as others has just what? Read, which is a 4. So you can see when you want to give a permission, you can now say, oh, this file, you are going to say, oh, we are going to do this, like the permission for this is now going to for is going to be, the permission for this file is going to be this number, right? Let's go to the, I just wanted to make you understand this number. Now let us go to the terminal so that I will actually now show you how we create a file and now we give permission. First of all, let us list what is here. Let's go back, let us list what is here again. So let's create a file at this directory that we are working so that we won't move up and down. So if we have a file called file.txt, right? We have a file called, oh, remember we use what? Make we use what? Touch to create a file, right? So we use touch to create this file, right? So we created this file, right? If I just list ordinary listing, I'm just going to see this file. But if I want to see, I created this file. If I want to see the permission on this file currently, see what I will do. I'm going to go, instead of ls, I'm going to use what? Ls dash a is for what? Hidden files. Y dash l is to show the length, right? Now let us look for my file. Can anybody see my file? My file is this first one, right? Remember I told you owner, group, and others, right? So currently I created this file, but see, I only have read and write. I don't even have execute, me that is the owner of the file, right? Then also the group level, it also have read and write, no execute, while the others level only has what? Read. So that is currently the permission of this file. Do you understand? But I want to give the user, which is this first one, me, I'm the owner of this file, right? I want to give myself an executable permission. So how do I do this? It's very, very simple. I'm going to use this. So it's either I put for the material, as in, remember when we, let's go back to our, if you want to give this permission, right? Meaning I can now I can only from this permission 754, it means the user, which is me that created it, I have all the permissions, right? The group only can what? Read and what? Execute, right? Why the others can only what? Read. If you want to give this permission, just watch this, right? Come back here, we use the change mode, right? We use the change mode and we put the number. In this case, in our own case, what's the number we want? In our own case, we want what? 754. Now you know what that number means, right? 7 means the user or the owner has what? All permission, read, write, execute. 5 means what? That the group level, they can read, they can execute, but they cannot write, right? Then 4 means that these other people can only read. Now look at what we have before. I can read, I can write, but I cannot execute. But by the time I run this code on the file, don't forget to put the file name, which is what? That's the file you are trying to change the permission to, right? Change the permission to. So now look at it. Before now, I can read, write, but I cannot execute. Why the other people can just read and write, no execution, but this guy can only read, which is also what we've done. It can only read. This one is read and write, which is correct, but I'm going to give myself extra permission. If I run this now, right, and if I now check the file again, you can see I now have read, write, and execute, which I wasn't having before. Are you seeing now? Read, write, execute, right? Remember before, the user group have read and write, but in our own case, we say the user group should only have what? Write, as in it should be able to read and execute. We have, by just using that number, we have changed the permission of the group to now just, we've removed the write permission and now we are giving them execute permission. Why? For the others, the permission still remain. So just by doing that alone, we've actually changed the permission of this. I hope you understand. Let me give you another example. What if I don't want to change, I don't want to write these 3 numbers, like I don't want to change for everybody, I just want to change the group permission. So at the group level, currently at the group level, my group can read, they can execute. What if I want the group to also be able to write? How do I go about it? for the group I can just like this, right? Group G to show group, and what permission do I want to give to them, right? I want group to have what, I can say I want group to have, what did they not have before, let me see, they can read and execute, but I want group to be able to write, right? I'm going to do this for, don't forget to always put the file that you are changing the permissions for, right? If I do this now, if I check that of group now, you can see that I can read, write, execute. Me, I can read, write, execute. Now also the group can read, write, execute. So that's how you add. But what if, for example, I want to remove read and write from a group? I just want the group to execute. How do I do it? Right? I can, or I want to remove the write. I don't want them to write. I don't want them to be able to write to the file. What can I do? I'll go back here. I'll say for the group, but instead of saying that they can write, I can remove that write again. Instead of plus, I'm going to be using minus to remove that. And if I go, right, and check again, now you can see they don't have that word write permission again. So I can use, and that's for group. If I want to do it for user, for example, if I don't want user to have the execute permission again, I can also do change mode, but instead of, I'm going to just change this, right? So it's going to be user to show there is a user. Then I'm going to remove which permission I want to remove. I want to remove that I don't want user to execute. So if I do minus s, meaning I'm minusing that, right? I don't want them to execute. Now if I go again and list it, you see that my user does not have that executable permission. So you can actually use WRX, or you can actually use the number, right, to be able to actually manage this permission. I hope that helps, right? What else do I need to cover about permission again? Let me see. So we can see how we can give group, as in give permission numerically, or how we can actually just give permission. So if I also want to give the user the right access, no, I'll just specify u for user, and I'm just going to give them the right access. Now let us create a simple script. I just want to show you what the power of that executes, right? I want to just quickly create a simple script. It's a very simple script. Remember, to create any file, we are going to use touch. In this case, let's call it script. But because it's a script, we are going to call it script.sh, right? I'm creating a simple script.sh. I've created it, there's nothing in it. If I do ls, my script is there, right? If I check the permission of the script again, remember ls-l, you see I created a file, script.sh. It's no extraordinary, it's just a normal script. But by default, you can see I have read write, I cannot execute it. Even group has read write, they cannot execute it, while others have just read write. I want us to edit this script and just write something very simple in it, right? How do we edit it? Remember, I told you can actually use either nano, good, nano, the name of the script. In this case, we have script, right, .sh. It will make us to edit it. So I want us to just easily write a simple script. Now, the start of any script for your kernel to be able to interpret what it is, like for the operating system to be able to interpret what it is. If we want to make this a batch file, right, so that it's able to interpret that, oh, you are not just writing anything random, it's a batch file. There's what we call shebang, right? We're going to actually, that's how you start the script. That's how the systems read it and understand that, oh, you're writing a script and I need to execute it as a code, right? So we are going to do what we call shebang. You start with the hash key, the pound sign, or what we call the hash sign, right? Then this. So for you to get this particular character, you press your shift, then your 1. Most times always on 1, depending on your keyboard layout anyway. So I'm not saying this is the fast rule. Then you have this backslash, right? And you are going to write bin, right? Another backslash, you are going to write bash, right? This is actually a bash script, and that's what it means. With this command, it's not hard. Like I said, the pound sign or the hash sign, depending on what you call it, the exclamation mark, then bin slash what, bash. There are other type of share script out there, but for simplicity, this is what we are going to use. And after we do this, the immediately the file rates it is going to this is an executable file. I should treat it as a code and execute what they do. So the first thing we are going to be doing, we are going to be like, what we just want to do in this script is we want this script that when we run this script, it's going to ask you what is your name, and if you tell it your name, it's going to print your name, right? So I'm going to say, first of all, going to say echo. For you to print something on the script, on the screen, you use the word echo. So we want to say echo, then we are going to put it in a curly brace, meaning it's a text, right? And we are going to say what is your name. It's as simple as that. What is your name? And we are going to close our string, right, to show that it's a string. Then so this echo is just going to write something. When you see echo, it's just going to write on the board, right, that it prints, it writes something on your terminal. Then what to read from the terminal is simple. Read is actually also a command. It read whatever it is that you put in the terminal. We are going to be reading name. In this case, name is already acting as a variable, right? Then so it's simple. When we run the script is going to run, and it's going to run this first line, and so what's your name. Now it will wait for you, meaning this reading is going to wait for you to input anything on the terminal. Anything you input on the terminal is going to be saving that thing inside the variable called name. Now this name, I can call it anything. I can call it shoe, I can call it bag, I can call it anything, but I'm going to call this name. Then when you read it, it's now going to say, we are going to echo it again, right? We're going to do echo again, and in this case what we are going to say, remember, put it in the text, and we're going to say your right name is. Now your name, this normal name is just a normal text name, right? But we are going to say your name is, we will look at variable, right? We are going to be looking at variable, but I'm going to show you how you write a variable. Your name is, I'm going to do a $sign to show variable, and I'm going to say name, right? At this point you can see the color coding is different, right? As immediately I type name, the color coding was different until I close the string again. The way it's going to treat this name is totally different from the way it's going to treat this name. It's going to treat this name as a variable which is coming from here, while it's going to treat this one as a just normal string, right? So at the end, if all things go well, if we run this script, what we're expected to have is that immediately you run the script will tell you what is your name, right? Then it will wait for you. This read means that I should hold on and wait. Once you put in your name, this is now acting as a variable. This name here is different from this. This is just normal character words, right? This is just a normal word. But this one with this is not a normal word. It's referencing whatever it is that is here. When you say what is your name, and you enter anything with your keyboard, whatever you enter is going to store it in a name. So when I say echo your name is, meaning print your name is, whatever it is that you enter here is going to be this value, right? So now that we've done this, remember, how do you save and is just do control what X. Oh, do you want to save? Press yes, which is Y, and press enter. Now we have a script to run. The question is, can we run this script? Because remember, when we check the permission of this script, that's just the power of permission I'm trying to explain. When we check the permission of this script, we can't really execute it, and it's an executable code. What makes it an executable code? Because of that shebang we put, right? That shebang to show that it's a bash shell, right? So, but you see, it's not executable. So if we run this script now, what do? Let's just write script. Okay, we are just going to let me see again. Yeah, ls, right? Okay, so we have our script. So if I just want to do script, right, by saying let's say we want to execute just script, right? Wait, what do we save it as? Okay, we save it as script, right? So we are going to say script.sh. we are going to run it like script sroi, right, pt script.sh, right? That's what we called it, right? And if I press enter, you see it's showing no such file or directory. Did I put dot? Yeah, it's showing, oh, this bash, see, is a bash this.sh, no such file or directory, and we are actually in that, yeah, we're actually in that directory, but it's not seeing any executable, so it's not able to execute. But let's not conclude. instead of running it like this, we can either run it like this or we just call the bash on it direct, right? So let's do this instead. Let's do bash, then the name of the script, right? You see, I hope we are script sroipt. Oh, there's an error in my scripts. So there's a typo error. S S uh sorry S SC, yeah, SCRIPT. So yeah, this is correct now. So if we press enter, yes, this is what we're expecting, right? It say permission denied, and most time you will get this a lot. You are trying to execute something, it's showing permission denied. I created this script, I'm trying to run this script, it's telling me I cannot run it, that I'm being denied. Why will you deny me? Because when we check this script, right, when we check this script, remember, I don't have the executable permission, so I cannot run I cannot execute. So what I just need to do in this script, remember, is just to make this script executable. I didn't make it executable, is to make it executable, so I can even make only the script executable. I will now see the permission. So how do I do that? Remember, to give a script permission, you do what? Run what? The change mode on it. So you do change mode, but I'm going to say plus S. Now if I don't put anything before it, it's going to give the 3 levels of permission. So if I make it plus S, right, then of course, what do I want to make plus S? Scripts, script script.sh. Now if I run this and make it executable, if I check the command again, now see, where is my script again? So you can see that my script now at all level, me, it has given me that permission. Listen, it gave me the permission, right? He gave the group the permission, and he also gave what? The others the permission. Before now, if you check it, I don't have the permission, group don't have the permission, others don't have the permission. So most time we are so quick to type change mode plus sh and give everybody the permission, but I don't still want to give everybody permission. I want to give only the user the permission. How do? I'm going to remove the permission I put, right? I'm going to do something like this, right? If I check again, I've removed it for every other. Remember, if I don't have anything prefixing it like group or user, it's going to apply that permission to everybody anyway, right? So now if I check the permission again, you see it's back to the default. But in this case, I just want to give only the user. So instead of, it's going to be u plus, right, x. If I do this now and I check the permission again, what do you see? You can see that script. Me, I can execute it, or group cannot execute, others cannot execute. Now, can this script work for us? Can it run, right? Can we run this script? Let's try run this script again by using how do we try running it before? We can use bash, or we can just call the script.sh direct. If I run this script, now you can see the script run, and it's asking me what is your name, and because of that read, can you see it's holding on, it's reading, it wants to read what is on my key, and I'm going to say my name is what? Victory, right? And once I press enter, I get your name is Victory. I can run this script again and you say what is your name, and I can say my name is let me say Zora, right? And what do you think it's going to do? Your name is Zora. Do you understand? If I run it again, what is your name, and I say my name is ABC, even anything that's not a name, guess what? It's going to print that for me. Now I use this as an example to show you that it's not, so you can't just be happy and like, oh, this script is running fine, but there are not a lot of graduate to make sure that the person actually enter a reasonable name. Names don't have numbers, we all know that, right? But you can see this is having that, in that's for another day. But that's actually how you can see these permissions. If I remove these same permissions now by just running this script, but instead of doing user plus and I do user minus, this same script I'm running, if I run the script again, I'm going to get permission denied. So you see why permission is very, very important. I hope I'm seriously hoping, because permission is key, I'm seriously hoping we cover permissions. So the next one we are going to go, and like I said, permission, when giving permission, you can actually use what? Numeric values, or you can actually use what? You can actually use the character. It's always easier to use this, right? but sometimes we use the numeric value. But you should be able to understand permission. So when you see something like this kind of permission now, for example, right, you see 7, for example, you have 700. It's easy for you to like, oh, the owner has the full permission, right? The user has the full permission. Why user and group don't have permission? The common permissions you see, this is very wrong. Let me not say it's very wrong, but most time I say ourselves, we see you're running a Docker container, you are giving this is full permission, meaning everybody can read, write, and execute, right? Everyone on the system. This is dangerous when you are working with containers anyway. Nobody does this anyway. So these are common permissions. Then you are also have permissions like this 744, right? So they are just different permissions, like 755 also, right? 755 is okay, the user have all the permission, while this one have what, read and execute, right? There's what we call 644 also. The owners can read and write, the group and others can only read. So depend on the sensitivity of the file that determine how you set those permissions, right? Okay, so that being said, let's not overflow permission. Let us move on. I have a cheat sheet I'm going to share so that you can also follow through and see if there's any part that will miss. I'm working on a cheat sheet to share with you. So that being said, let us move to how to create users and group. How do you create users and group? I'm going to clear this, right? Oh no, it's not going to work. So I'm going to clear this, right? So the next thing is, how do we create users and group, right? First of all, I'm going to find out, I'm on a system. Who am I? Which user am I? Who am I? So you do who, right? Am I? It's as simple as that, right? If you do am I, it's going to show me my username. Oh, you are get techie, right? That is the username I am on this group, right? So with who am I, I'm going to know who am I. Then also, if I run ID, right, I'm actually going to get to see my user and my group ID. So for example, you see my user ID is this, which is get techie. My group ID is this, is also get techie. For every user you create, it creates the same group on the same name, right? So I have a group called get techie, right? So it's actually able to tell me where am I, what group I belong, right? Then if I do group also, right, it's actually going to show me the groups that are actually present on this computer. So what are the groups? There's the get techie group, there's the ADM group, sudo group, and those groups that are present on this computer, right? How do I create a user? So I'm going to clear this, right? How do I create a user? It's simple. It's as simple as, but for me to be able to create a user, I have to have administrative permission. Now let me tell you what I mean by that. First of all, I'm going to create a user. And how do you create a user? It's very simple. Just say user add, right? User add the name of the user, which is the username. So let's say I want to create a user called Victory. So if I do user add Victory, it's not going to work, right? It's going to give me permission line. Why? I don't have permission to write to ECT files, right? Where the passwords are. I should try again later. But if I come and do sudo, right, add user, meaning I want to use a privilege account, then I'm going to enter the privilege password that I have, right, like an administrative account, right? I'm going to enter the password, and now that I have the password, I've actually created that user, right? So if I try creating that user again, it will tell me the user already existed, right? So another thing, if I go to my home directory, remember where am I currently? Present working directory, right? I'm in get techie. But for me to go to my home directory, for me to go to my home directory, I can just come and say I want /home, right? And I'm able to actually navigate to my home directory, right? Oh, home is not a directory. Okay, so if I go to home, right? Sorry, cd home, right? So if I go to my home directory, right, and I do ls, I should be able to, oh, these are the users I have before. But depending on how you create the user, right, I can either see the users here if I had a flag that I want to be able to manage this folder and user, I want to be able to see this user here, or I don't have that. But from my home directory, I think these are the users I have created that I can see. But to add user, use add user. But also you can actually set a password for a user. How do you set a password for a user? Remember we added user called victory. How do we set password for that user? You just use the word pass, wd. It's not full password, password, right? You put password, then the name of the user. In this case, victory is the name of the user, right? So when you press enter, right, you may view of sorry, password, you may view or modify password for victory information. um Coming, let's do this. Sorry, let's I changed directory, so let's go back to where I was before, although it has nothing to do with this, right? But we're going to, yeah, so we're going to do sudo again. Then let's do pass wd, right? And we are going to do victory. It's supposed to tell us, so you can see we need to set new password for victory, right? So you can actually set 1 2 3 4 5 6, repeat the password 1 2 3 4 5 6, right? So of course don't set as silly a password as 1 2 3 4 5 6. So you can see we've actually set password for a user called victory, right? Can we add victory to a group? For example, can we create a group and add victory to a group, right? So first of all, let's create a group. Let's create a group called docker group, right? How do you think we create a group? Simple. You know, when we use user add, it's as simple as using what group add, the name of the group. Let's call it docker, for example, a docker group, right? Permission issue again, remember you have to be an admin. So you see that you actually sudo su and remain an admin, but I don't want us working from admin, so it's just better we do what sudo group docker, right? And now we've created group. If I do group again, right, if I check group again, groups, if I get group again, so you can see we have get techie, we have oh, I didn't put that flag again. So yeah, we can check that in where are we now? Lost my chain of thought again. So let's clear this, right? So we've added a group, right? We've added a group called docker, right? We want to add the user we've created to a group. How do we go about that? So we want to view groups, right? Okay, to view groups we can actually just like check the yeah, we can check the groups, right? Then groups. So let's do this. Come on. Yeah, my autocomplete is not working. My autocomplete is not working. Okay, so but you can see we have the docker group. Like I said, when you create a user, it creates its own group. So we have the docker group and we have the victory, right? So what we want to do is actually put victory in the docker group, right? Like we are going to add victory as in the docker group. That's what we want to do, right? We want to add yeah, is that not what we said? We want to add victory in the docker group. So how do we add victory in the docker group? So you are just going to change the mode of that user, right? So you are going to do something like this called user, like more or less like changing, modifying the user, right? But the user, but you are going to use this, right? We are going to be appending to, because remember I told you any user, when you create a user, it comes with its own group. But now we want to append another group. We don't just want to, if you don't put the a and just put group, it's going to like more or less like wiped out whatever group that was there. So this is actually how you append group, and we want had to be in the Docker group, or victory to be in the Docker group, right? And which user. So we have, like, we are modifying the user, right, with this flag to append to the group. What was the group name? Docker. And what username are we looking at? We are looking at victory, right? So yeah, permission issue. So always use sudo to make changes to this. So now we've actually add um victory to the Docker group, right? So yeah, which other parts have we missing again that we need to cover on group and permit? Okay, we've looked at permission, but we've looked at how to create user, how to create group. Now the question is, how do you even delete user? Oh, that's another thing we did not cover. How do you delete user? How do you delete a group? It's very simple. You just go like this. So sudo, want to delete a user, simple. User deal, like delete the name of the user, in this case victory. If we want to delete them and remove their home directory also, we can actually still use this flag to delete their home directory, right? So you can see, oh, victory not found. So okay, we never we didn't have it here, so we're just going to do this. Let's do this. So user victory does not exist because we've actually deleted the user victory, right? Okay, so that's that, right? Then what else do we do? Then of course you can also use group delete to delete. Let me see, sudo group. Which group did we create again? Docker, right? So we've also deleted the Docker group. If you try deleting it again, you get that it does not exist. Okay, so now let's move on to more important ones, like what are the things we use every day. For example, file searching. Like, you have a file, right? You want to search things inside the file. It's either a text file or what. Or the networking is always very key in Linux. Or how to even manage system, like disk usage, memory usage, right? So we'll quickly look at that. I won't be diving deep. I'm believing you are having an answer now, so I'm just going to be quickly moving so that this video will not be too bulky, right? So I want us to first of all look at how do we search things in a file, in a text file, right? Like, okay, so for example, like I told you, most time we can have a log file. How do you actually search for some keyword in, you are finding something? For example, you want to look for 500 error, you want to look for 200 status code, you just want to look for something in that file. Do you have to go keep reading all the file? How do you search that? So that's what we'll be looking at. Like, we'll be looking at how we can actually search file patterns. Then after that, I want us to quickly look at the networking. Then also the major one, of course, disk and memory management and all. Then we can now actually, with this knowledge we've gathered so far, put up a little script and actually see how we can now put this into automating and repeating, that whenever I run this script, I'm actually able to get something out of it. So the first thing I'm going to be doing, let me first of all see what we have here. Do we have, yeah, we have some text file here. We have a text file here, we have a script here. So I'm going to clear this. So first of all, if you want to find a file name, it's simple. You use the word find. So for example, I'm looking for a file name. There are a lot of files on this system. I'm looking for a particular file. So I can say I want to find in this directory, but I want the name of the file. Are you seeing now? By saying dash name, I want file.txt, right? I want a file like this. It's actually able to search. Oh, I have some permission denied. Wow, I have a lot because I'm using the root directory, right? So let me do this, right? So I want to find, right, the name, and now you can see I'm not only seeing the one that is in this directory. You know, when I did that first permission, I'm finding it in the whole system. Like when you are looking for a particular file in an entire system, so you can actually use that flag. Like what I mean is, you see, using this flag, meaning from the whole root directory, And that's why you see it find a lot of things and gave me, oh, you don't have permission for this, you don't have permission for, especially the proc part, right? You don't have permission for this because there are a lot of file, but I don't have permission. But when I restricted it down to, okay, fine, remove this, meaning this root, and like in my current directory, this directory I'm working on, can you find any file name called file.txt? It was able to locate two of it for me. First, file.txt, which is currently in this root directory, and also remember when we had folder 2 and we have file.txt. So that's what find does. It finds any complex file for you and it's going to tell you wherever you have anything called find.txt. If I have used this command and use sudo, like just have that permission, right, I should be able to also like is it this command? No, yeah, was it that command? Yes, to just find more, right? So that is that I can actually find file. For example, instead of this, if I do find again, and instead of find.txt, I say script, for example, right? It's able to actually find that I only have a, oh, come to think of it, I thought I only have one script because I'm using this, but because you see now, it's able to help me find my script.sh, but also checking, are you seeing this part? Seeing that on this part there's a script.sh, on this part there's a script.sh, so it's kind of find because of this part I'm using. If I remove that part, right, if I remove this part, it's just going to find the one in my current directory. I hope we get that. So it helps us to be able to find a lot, right? So another thing we can also do, right, is to tell that, oh, the part or the type of file I want. So you can actually still use find, right, in the directory, but what kind of file do you want? You can now say type, like I want this type of file, and you want that the type should be a file and what should be the name, right? You can also put a flag called, oh, I want the name to be anything. So in this case, I want the name to be, now look at it, you are not really sure of the name, but you want the name to be anything that has to do with .logs. So you are now, in this case, you are looking for log in an entire system. Do you get what I mean? So it's going to find anything that has to do with log file on the system. Do you understand? So for example, if I quickly do something like this, touch, right, and I'm going to write it in a folder 1, I'm going to create a file in folder 1. So let's do, is it folder 2, is it my folder, sorry, yeah, my folder 3, my folder 2, my folder 1, right? And I'm going to have um let me just say something like this, testing.logs, right? Let me just put something like testing.log, right? If I do this, right, and I run that file again, you should be able to actually see, because I say of type file, and you should look for anything that, okay, of type file, sorry, not type log, but like it's able to actually look for anything that has to do with maybe something end of. So there are sometimes you have a lot of log files, right? It's actually going to look for that file that has that log file. Let me that has that log file. So depends on what you are looking for and how you filter it. Another thing I want us to do, let me let's do cat. Let's see what we have before in our file.txt, right? Oh, I thought we have a file.txt. Yeah. So if we do cat, don't we have anything in file.txt? I thought we do have something in file.txt. Really? There's nothing in file.txt. Where were we writing to? Oh, mini cards. Let me see. My folder 3. Oh, is in my folder 2, right? Then a file.txt. Oh, it was the one in my folder 2 we wrote to. So let us look for a particular word. I want us to look for a particular word, because sometimes you might be looking for something like error 500, error 1000, right? So but in this case, let us look for a particular word. Let us look for the word write, WRITE, right? Like I said, it can be anything, right? So we want to look for that word, right? So one of the things we can do, right, is to actually do what we call the grep, right? It helps us to be able to actually hold something. We say, oh, we are looking for the word right, right? we are looking for the word right, right? We want to look for, yeah, the word right in the file. Which file? Remember, our file is actually in my folder 3, my folder 2, right? And it's now in file.txt, right? So if we run it, can you see it's actually highlighting where it has seen that word right? Can you see right here? Can you see right here? So there are sometimes, like I said, we might not be looking for a particular word. Of course, you can also write a script where you're looking for, oh, when you have this kind of word, this is what you should do, right? But most time you might be looking, you need to look for also error code in your log files, right? So you actually use grep to be able to look for a particular thing, provided you provide it. So you can see grep, this is the word we are looking for, right? If you see check again, we can actually see grep and look for because. So we can take this up instead of right, we look for because, right? So if I come here, right, it's going to show me where it has a because in the file. So it actually helps us to be able to easily narrow down rather than having a very large text file, right? And you are scrolling to look for a particular word. You can actually use grep to get hold of that particular word, right? So like I said, it can be error, it can be this. Also, you can actually do more filtering. Sometimes it's, you are looking for a word but you want to ignore case, right? So for example, now we have grep, we are looking for because, but we want to ignore case. Like we don't want it, we need to ignore, I don't want it to be case sensitive. Just put the flag ignore case sensitive and it's actually able to get that word because we are not interested in a case sensitive, right? So those are the those are those are what you use to find file system. Of course, there are a lot of flag command, like I said, will not be covering. I just want you to know that, oh, this is possible. You can actually find a path, you can find a folder, you can also actually what grab for a particular one. Then of course there are other things that you might want to know. For example, you want to know, for example, it's very common when you do which Python, if you want to know the Python version that is on your system, right? I don't have any Python. That's why is you get, you can actually use which Python or where is this, right? You can, if there is a Python, you can use the word where is. You can use where is Python, right? And tell you that Python is in Python. Do you get? Or where is something like nginx, for example? You want to know the part nginx. There's also no nginx on this. I'm just using it as an example of what we do every day, right? So there's no nginx, there's no Python, right? But if there is, actually it's actually able to tell you the part that it's located for any of those program file that you already installed. Do I have anything installed on this system? I don't think so. But okay, yes, I have snap installed. So when I do where is snap, it can tell me that, oh, you have snap installed, and you can find it in user bin snap. Are you seeing it now? So it's actually able to tell you when you, or if you have which, like which of this, right? So for example, so if I can still do something like this, like which snap, then it's going to tell me, oh, this is where it is, right? So this is actually how you also know where you, as in where your package is. Okay, so that being said, you can do it, you can read the documentation. To be honest, you can do much more on that, but that's just for you to know that you can actually find a part on your system. For example, I think we do that a lot with Terraform. When you have a Terraform, you don't even know where it is. You have a Python, you don't know the part the Python is, you don't know which Python. You can actually use those commands to find it, right? So the next one I want us to quickly look at, which is very important, is disk usage, right? We want to be able to know our file system, the storage, what is being used. So what we easily use is df, right? We use this a lot, but most time you see it like this, you might not be able to, it's not in a human readable format. Yes, you can read it, but it's also a point, just do dh and just put, remember, flag again, h, to kind of, you can see, unlike you reading these wider numbers, it's kind of more easier to see, oh, this is our file system. Oh, it's 98 gig, right? The total size. What are we use? We've used 14 gigs so far. How many do we have available? We still have 14 available. What's the percentage we had with percentage and other term file? So it's kind of easier for you to see your file system usage. Another thing is you want to know the size of your current directory, right? If you want to know the size of your current directory, you use du. Remember, you want to also make it you can use du dash sh, right? Then the file, the as in the total directory size, that's the directory size I'm on now, is just 3.2 MB, right? You can also want to find out the directory size of a particular um I don't really have any file on this system, to be honest, because I just created it. But you can actually specify a part you want to know the size, right? And it's going to tell you, okay, this one, this is the size of this file. For example, if I want to actually know the size of the script, is it the script now? But you just want to know the size, like the size of a particular part also, right? A specific directory, you want to know the file size, you can actually use du-sh, then the part that you want to know, and you are also able to know. Then if you also want to know the block device that are available, right? I think you can use lsbi lsblk, right, to be able to know what are the block device, like like what are the block device that are available. You're actually able to see the size. So when we check, you can actually see that initially this is on my file system we only saw 100 gig, but we have more, right? You can see this one is about 930 something gig, right? So that's the old block, and that's what it's been like. Should I use the word partition? And it is from here I have my Ubuntu file storage. So you can actually use that to know your block storage and all of that, right? And also, if you want to know any file system that is mounted, just use mount to be able to actually see the file system that is mounted. Okay, so now you are asking me, why am I doing this? We will actually see the use of this later, especially for example when you are debugging for any reason. You want to check this system metrics. You want to check that open, there's no pressure on the disk. Is the disk usage, is he already, am I utilizing up to so and so percentage that is causing this crash or this error? Those are the things, and for you to get, you need to know how to fetch it, then use the information you get to manipulate and get output on the result. So that being said, let us quickly go over to the networking, right? For example, you want to know IP address on your system. This one is very key. Just do IPA, right? You want to know the IP on your system. In my own case, I'm actually connected to a Wi-Fi and interface, right? So it's easier for me. I'll just look for the Wi-Fi interface. This is my Wi-Fi interface, and you can see I told you that this actually an internal network is connected within my internal network, right? So I have the WLPS2, right? P2S0, right? So from here I can actually check, look at it, is up. So see, from here I can actually check my internet, and see I actually have my IP address here, right? And I can also see my MAC address and all of that. So you can actually use that to find out. Another one you use is IP route. IP route actually tells you what routes do you have, right? Let me try zooming so that I'm trying to see if I can zoom in. Let me try zooming so that you will see how so you can see IP routes. You can see these are the post routes that are currently available, right? On this, the ones that are currently like the route on this network, right? So you can actually check the IP route also. Then another thing is you want to test the connectivity. That one is very common. You don't even know if your system can call out. I think there was a time I set up a server, an EC2 instance, right? And I tried to run the update and it wasn't updating. Not knowing that yes, I set up an EC2 instance in a private subnet, but not knowing that that private subnet was not even having a NAT gateway. So there was no way that that server could have outside connection to be able to download the update that is required. So one of the things we normally do is to perform the ping, right? You just ping Google is a very common. If you ping google.com and you get packets back, you can see it's responding. So it therefore means that this guy actually have access, right? So just keep sending receiving packets. Then you can just control C to just end it, and it will tell you that, oh, I've received about 10. I send a transmission, I received 10 packets, 0 packet loss, and this is the time, right? If there is no internet, it's going to you are going to have a you are not going to receive anything, and you are going to have about 10 packet loss. So that's actually how you ping. It's just for you to check, do I have external connectivity? Is very cool. Then another thing is we use call a lot. For example, you also want to access Google, right? Or you have an application, you want to actually test it. Unlike, you are not going to go to Google Chrome and check the application. You want to be able to call the application and see if it's actually working. So we can actually call something like https, right? Https, right? We can actually do this and say google.com, right? And if we do this, oh, see my https, so sorry. So we can do https, and you can see that we've actually received an html file, right? So you can actually use this one also to test some endpoints that you just call it. Like, instead of going to the browser, you can actually call it, and you're able to use it. Then you can download. To download, you just need to get you do this widget, then the URL that you want to download something from, right? If you pass in the URL, the http URL, right, then you're able to, like, oh, I want to download this thing. It actually downloads on your system, right? Then you also want to know another thing, that you want to also know the ports that are available, the ports that you are listening on your system, right? So I don't know what I can download, but if you want to download anything that you have the download link, if you put widget and you put the download link URL, you will actually be able to download that particular thing. Then, like I said, if you want to check your ports, so you can actually use this. I use TCP UDP. I try to always remember TCP UDP listening number process, and it's going to tell you the TCP ports that are up, the UDP ports that are up for this particular system, right? So what else? Yeah, another thing you can do is to actually do what we call NS lookup, right? That's the name server lookup. So you can do NS lookup. We do this a lot. So if you can do NS lookup, you can do google.com, you'll be able to know who is managing a particular name server. So we have NS lookup, name is google.com, this is the IP address, google.com IP address. Can you see? So you can actually use this one to do NS name server lookup. Then which other thing again? If you want a detailed DNS, yes, most time you want a detailed DNS of a server. I think recently, well, like yesterday when we were working and we are doing what we call DNS management, where we had we bought a domain on GoDaddy, but we wanted AWS to manage the DNS for us, and we actually created hosted zone on AWS, then copy the NS to GoDaddy, right? So when we did that, you can as well just come here and do what we call the NS, like it does. You can do the NS lookup, but if you want a deeper, you can actually do what we call dig, right? And we'll do that. So let's do dig google.com, right, to actually have a detailed NS lookup, and we can see, okay, so this is it. So if you go, you can actually dig into the NS lookup to understand where it's coming from, who is managing it, the server, and all of that, right? So then which other thing again do we use? Of course, we need to know where are we. What is, we use host name, right? What's our host name, right? This is the host name of this particular. You want to use your understand your host name. Once you type in your host name, because you use this also for automation, you need to know your host name to be able to run some things, right? So when you type host name, you actually understand what is your system host name. So I hope that is clear. Those are just what I can come up. There's a lot that can come up. I'm just trying to round up this. So another thing I want us to quickly look at, right, is system monitoring. That is very, very key. As a DevOps engineer, that is our day-to-day work. So I want us to quickly look at system monitoring, right? So there are sometimes you are debugging and you want to be able to see what is happening on your system. So the first command, of course everyone know, is the top command that actually gives you process, what is running on the process. Like it's a live report, right, of your processes, what is running, right? So you use top a lot to understand the CPU, the memory, the uptime, and all of that, right? So you use top a lot. Then I'm going to control C, right? Then another one you can use to understand, if you use htop, I don't know if I have, if you use htop, yeah, htop give you this fine, like this fine color view of the same top, although depends on the system you are, whereby you are also able to like, you know, see it in a more nicer way. Let me use that, right? So we have the memory, we have the CPU, the uptime, just what you could see, right? So we actually have it, and you can see the processes that are running, who is running it, do you get, and all of that, right? So remember, control C again to leave here. Then most time you want to see your running process to see what is running currently, right? PS, right? AUX, right? You're able to use one to see the current running processes also, right? You see the running processes, you see the CPU utilization, you see the memory utilization, you know the process ID, you know the process to queue. So this actually how you view then your running process. Then if you want to know your memory, you know we talked about disks the other time. How do you know memory? If you do the word free, okay, let me clear this so that it will not be too. So if you use free, right, free is actually able to show you your current memory, right? Let's make it in a, I like using -h. It will make it a human readable format for us. Can you see? It's far better when you put this flag, right? So you can see total memory of this system is about 7 point something gig, that's 8 gig. What memory have I used? I've just used 2.4. How many memory is free? What is the share memory? What's the buffer? What's the swap file? Do you understand? What is the available memory? So you can actually see memory from here, because most time when you are debugging, you want to check that these matrices are right? This is where you even start from. Where I say, oh, how come there's no memory? What's consuming the memory? Then you check the running process. Notice that a particular process is taking a lot of memory. What is this process? Why is it taking a lot of memory? Is there a memory leak somewhere? So you just go down the rabbit hole of debugging this whole stuff, right? Okay, so that being said, yeah, we look at free. Then also uptime, of course you can also see, get all of them from top, right? But you can check the uptime of a system too, right? Or and the load, not just uptime of a system, but uptime of a system. So how long has this system been up? You can see it has been up for about 30 yeah, 3 days now, right? How many users do I have? This is number of user. What is my load average? Can you see there's actually no load currently on this system? So you can just type uptime to check the uptime. But there's one that we use a lot, which is called the VM stats, right? We are checking the stats. That's more or less like the statistics of that VM, the performance, right? So you can actually see your VM stat. You see is if I zoom in a little so that for it not to be cluttered, you can actually see the process, the memory, the swap, all of them for the uptime, which you can also see also in the sorry, for the VM statistics, right? Just like the performance statistics, right? Then also there's the what we call the I think IO stats. IO stats you can actually check for both the CPU and the disk statistics, right? Can you, yeah, IO stat. Let me IO stat ST8C. I remember. Yeah. So yes, the IO stat you can actually see, check the statistics. You can see the average CPUs, right? And also the disk. It gives you those information. So we use now you might not understand why we are doing all this, but when you actually start writing script and automation and debugging, you need to know, as in to use this to fit in that. Okay, what's the upstart? Okay, if the upstart is like what's the meaning of this? I think that's where the beauty start coming in, when you start putting them together, right? Then another thing I want to quickly explain to us is process management, right? Process management is actually how you manage processes running on your system, right? So how do you start a process, how do you stop a process, and how do you control jobs, right? After this, I think I will be another thing I want us to know is actually jobs, like chrome jobs, because we do that a lot. When you want something to run at a particular time in interval, right? We do that a lot also. But let us, how do you start a process? You know, remember I showed you that for you to know process that are running, more or less like to know the applications that are running. Okay, so let me come back to what you know again. You know, sometimes your windows become somehow slow, and you want to go to the task, you want to go to the task bar. Let me bring it out. See, you want to come to something like this and actually see, oh, what is running, what is making my system to be slow, something like that. Maybe you are eating a lot of, what is using my power, what is this. You can see it's easy nice there. Just type task manager. You are actually able to see this. You see, can see my Spotify is running, a lot of things are running. What is taking a lot of memory, right? So you can actually see, you can go to performance to see how your system is performing, for example, just giving an instance. So how do we do that on in Linux, right? How do we manage process? I told you, first of all, for you to see a running process, right, you use what, a PSAUX, right? PSAUX, right? You can use this one to actually check for a running process. Now the process are always too much. Sometimes you just want to narrow down on a particular process. So for example, I can say, remember now bringing it together, right? You can now say, oh, when I run the process, which is PSAUX, right, I want to pipe it. This is a pipe operator. Like whatever result I get, I want to filter it by using, remember what we say we wanted to use filter, by using grep, right? That's whatever it is you get, go through it. I'm looking for a particular process with a name. So let me say I'm looking for a particular process with a snap, for example. Are you seeing now? So it now filtered that, rather than me just going through all this process and start looking for, hey, which process am I looking for, which process, so is so much. Just use the filter, which is the grep command. Can you see? Immediately I do run this filter means whatever it is, whatever result you get from here, pass it like a pipe, meaning pass it like a funnel. Then use it, filter, grep means to filter, and look for this particular name. Immediately you did that, see, is a process running. Are you getting now? This is where it's running. So first of all, the process ID, I'll be able to see all of that. Let me zoom in. Most time you need to zoom in to actually see the whole beauty of it. So you can see, first it's running as a root, then I'm also running it here, right? This is the process ID, right? So you can see, and from here now I can now even kill this process using the process ID. If I want to kill the process, if the process is consuming a lot of memory, I can just come and say kill, then the process ID, in this case 25514, right? If I do this, it's actually going to stop that particular process, right? I hope we get that. So most time we have a lot you are having engineers running, having a lot of processes running. That's actually how you can trace a process and actually kill that process using process ID, right? Then also there are sometimes that the process is very stubborn. Let me use that word. It refuses to go. Then you can actually now use what we call, you are going to use queue. You are still going to use queue, but rather than just the process ID direct, you are going to use -9. This actually like forces, then with the process ID, like it forces the queue, it forces the termination, right? It forces it. What I'm simply saying is that, let me go back again to this, right? The example I used earlier, like when I mean you kill a process is, let me show you the example I used earlier. So if, for example, if I come here and I notice that, oh, a particular process is consuming a lot of memory, right, I can just click on that process. For example, right, I should be careful the process I click. For example, I'm using this particular application for my screen recording. So if I kill this application, I've destroyed everything I've done. I'm just giving you an example. You can see Google, I have Google running, I can click on it and kill it. Immediately I kill it from here, just click on end task or right click and end task. It actually closes that application. So it's the same thing that by you looking for the process here and actually killing that process. I hope that is clear. Okay, so if you want to force kill it, you actually use the flag 9 to force kill it, right? Then you can actually kill a process by name. If you actually know the name of the process, right, you actually kill it by name. But instead of just say kill engineers, right? So for example, I want to kill engineers, right? Instead of you just saying kill engineers, you are going to put something like pq, then the name of the process, engineers, right? But in this case, I don't have engineers, to be honest with you, right? I don't have engineers, so it's just going to be a waste of time. There's nothing to queue. I don't have engineers running. But imagine I have my engineer server and it's taking a lot of process. I can actually kill it by name or kill it by the process ID, right? Another thing I want to do, I can do jobs. Let me clear this. Jobs actually show you whatever background job you have running. It's very important because you have a lot of background job running. You want it to do something at a particular topic time. So currently, if I just do jobs, right, I don't have any job running, right? But if you have any background job running, right, if you do jobs, you're actually able to see your background job, right? Then of course, if you use which other one? No, I think no ops no ops can actually keep job running, but we'll be looking at job very soon because job is also very key. So you use these things I just show you for process management, right? You use them to manage process and all of that. So another thing we've done a lot. This video is getting longer than expected, but I just want you to be able to understand how it all plays, right? So another thing we should also notice that there are different package management. I would have said this one earlier. There are actually different package of Linux variants, right? There's Ubuntu, which is the Debian package which we are using, and it uses sudo apt. For example, you want to update your system, what you just have to do is sudo apt update, right? To update the system, you are going to be ask for the password. So immediately you enter the password, it actually updates the system. You use sudo apt to update. Then you can also use sudo apt to upgrade if you want to actually upgrade the system by saying sudo apt upgrade, right? Maybe you have a lot of package you want to upgrade, and if you don't want to be prompted, you want to upgrade, you can just pass the flag yes by default, and it's going to actually start upgrading packages for you. Can you see? Maybe there are a lot of packages since I've installed it, I don't think I've upgraded it or I've upgraded it, so it's going to run through the package and it's actually going to upgrade it for you. So also, apart from upgrade, there are sometimes you want to install some packages. So let's clear this again. For example, if I want to install package like nginx, right, I can still do sudo apt install. So you use this a lot. Install, I can just put the name of the package if that's actually how it's being recognized, right? If I do sudo apt install nginx, and nginx is actually a package, see, once I say yes, I can actually now have what, nginx installed, right? I can now choose to start nginx or whatever it is I want to remove nginx. I can also use that sudo apt to remove whatever it is I don't want. So you know that this sudo apt install nginx, right? I can still do something like I can do sudo apt remove nginx. Yeah, I can do, instead of install, I can do sudo apt remove nginx, right? And I will actually remove nginx. Do you understand? Yes, I want to remove it. So you can actually use apt to install. Is a package manager to install and to remove. Now, note that it's not only Ubuntu that is it's not only the Debian variants. There are a lot of OS variants. There are a lot of Linux variants. There's the CentOS, there's Amazon Linux, and they have different command, right? So you should also be conscious. If you try a command and it doesn't work, you need to even understand what is my system variant before you know the right command to use for that system. I hope that is clear. So um yeah, another thing I want to quickly walk through is yeah, there is this. So let me go to Windows. There are sometimes you have a, a different type of file. Like for example, you have what we call a zip file or an archive file, right? So how do you open a zip file? Let's quickly go through that, because we will see encounter that a lot. So now imagine I have this folder tutorial. I can actually right click on it and I will compress it to a zip file, right? And now you can see I have a zip file. Now if I have a zip file, if I don't have what I need to read that zip file, right now I can open the zip file because I actually have what I need, or I can extract all. Well, in that case, on Linux, how do we achieve that? We have to first of all make sure that, okay, maybe we have that particular directory. So what I'm going to do, I'm going to first of all have a zip file. Then how can we extract that zip file? Because most time the packages will be downloading. So we're going to be downloading a package and see how we can actually unzip that package here, right? So let's start by first of all, like, okay, what do we even have? Let's see, ls, what do we have? Okay, so we have file.tsc, my folder and all, right? I want us to be able to first of all, can we archive, let's archive script.sh, right? Let's archive the script.sh. How do we even go about archiving script.sh? So what I'm trying to say is, can we even come here? Where's our, remember our example? Okay, now we archive a folder called tutorial. But if I open this folder, can I even archive a file? Let's see. Yeah, compressed to zip. See, so we have tsd.1, and we can see we can actually archive a file. So we can archive a file, we can archive what, a folder. So how do we do that same thing? So let's try this script.sh. Can we archive it? To archive, we use the command tar, right, on Ubuntu. Then we do this, follow me. This flag C means to create a new archive. So dash C to create a new archive, right? We are also going to want to see what is archiving. So we are going to make it Vibros, and of course we are going to pass in the file name. So we want it to actually be, we want it to be script. So what should we want it to be, the file name? We can say we want the file name to be script dot what, tar, right, to show that it's archive. But what do we want to archive? Are you seeing now? It's very important. In this case, we want to archive script.sh. So when I press enter, now you can see I've actually archived script.sh. If I do ls again, right, I actually have my script. Of course my script is still there, but you can see I've actually archived this script. Are you seeing it? So that's actually how you can archive a script, and we can still do the same, right, for our my folder tree. Like we can archive all the things that are in my folder. So remember, for you to create an archive, you use tar, TARO, dash C is meant to create, V we want to see what is happening, F is the file name, right? What is the file name you want to achieve? So we can come and say, oh, we want my folder tray, right? Is that not what we want to archive? Yeah, but what are we really archiving? In this case, we want to archive a directory, like a folder. Are you seeing that? No, a folder called my folder tray. Are you seeing now? One my folder tray. So when I press enter, now you see, because we use this flag Vibros, it's going to actually show us all the things that it's doing. Remember when we archive my folder tree has a lot of things running in it, right? So we have my folder tree, but inside my folder tree we have folder 2, we have test of this, we have this, and we have these other log files, right? Testing logs and this, right? So we have all of this. right? So all of them is showing archive. So if we come and do ls again, you can see we have archived script.tar. We have also archived my folder 3.tar. The question is, when you have a tar, how do you know what is inside? Do you understand? How do you, for example, you have a tar, is there a way you can actually see what is inside the tar? So for you to do that, there's a command you use. You still use the tar, right? tar, but in this case it's going to be x, right, v, f. And what are you trying to see again? We're trying to see my folder 3, right? My folder 3, in this case, dot what, dot tar, right? So now the question is, what does oh, I think I'm missing it with creating. I'm coming. I think I'm missing it. It's tvf, right? It's tvf to be able to see the content. Yes, and we are able to actually see the content of the tab. So remember, to the first one, you use tab to create, to view what is happening, and the name of the file, right? Why the other one is list the content of the file, right? So this t actually lists the content of the file. V, vibros, show everything as you are working on it. Yf is the file name, right? So we can actually see, we can still do the same thing, but in this case, instead of folder array, we're going to do scripts, right? We're going to do script dot star this time around, and we can see the content of the script dot star, right? So we can see the content, the script dot tar, and the permission it all has. So that's actually how you can actually archive a file and also see the content of the file. But this one is just like archive, but sometimes we also want to archive and compress. They are actually two different things if you are used to archiving file. So that's just like archiving a file. There we have carved a file, we archive a folder, but and we also see the content in that. Another thing is, if you download an already archive file, right? How do you like um not just view what is inside, but how do you unarchive it so that you can actually run the content inside, or you can actually use the content inside, right? So in that case, you use, so let's see what we have again. So we have script.sh. I want to untar script.sh, right? So in that case, you can still use star, right? Then in this case, the flag you use is the x. Yeah, that was the way I was missing it, the difference between s and t. Xt f, the name of the file. Of course, we want our script.tara. So you can see it has actually untie it, right? And you can actually see that we have our script.sh, right? We have the untie, we have the script.sh. So at this point, even if I remove script.sh, right? If I remove script.sh, right? If I remove script.sh now if you check, we don't have script.sh anymore, and I run the untar script.sh again, right? Now if we now check, you can see we have script.sh, right? So that's actually how it works. You can actually tie and not tie it. Then another thing, that's when we are actually archiving a file, but there are sometimes we also want to like compress a file. Let me use that word. When you want to compress a file, for example, you want to compress um script.sh. So we're not going to use tar, we are going to be using what we call zip, right? Gzip. Then scripts, we are going to script.sh, right? At this point, we want to actually compress that particular file. So we do this and we have compressed that file. So if we list the part of it again, you see there's actually a difference between when you do .tar is mean is archive, right? But when you do zip, like when you are compressing it, that's when you have dot, are you saying now, we have this dot sh, right? Then dot gz, right? So that's actually the difference. This one is compressed, right? And when we check, remember when we do ls/l, like to check the everything, right? You are actually able to, let me zoom in a little for us to actually see it nice and neat, right? So you are actually able to see, um I was trying to actually check the size. Good. So in this case, how do we check for the size? Remember, I also told you you can actually check the size of a file. So how do we check the size of the compressed and the archive? I don't know if you understand what I mean. So how do we check their sizes? So why you might think this is the actual size, like, oh, these are the size, right? Yes, these are this I can't I would say these are not really reliable size, right? Because for example, folder 3 has a lot of folder. To just show you the entry point, like folder 3, meanwhile there are other folders, right? But remember, there was a command we used. Can you remember? du-sh. So I'm going to comparing, we're going to do this oh, du dash sh for, we want to compare, okay, we want to compare script.sh dot the compress with the archive. So let's start with the archive first, right? We want script.tar, right? We want script.tar. What's the file size? It's showing that it's 12 kb, right? What if it's script dot what sh dot gz? Can you see? One is just archive but not compressed, right? But you can see the difference. It's the same file they have inside, but you see the difference, right? One is 4K because it's compressed, while the other one is 12K. It's just archive. It's not compressed. Do you understand? So the next question is, how do you now, when you have a compressed file, how do you uncompress the file to be able to use that file, right? Because we'll be doing a lot of file compression and all, right? So it's simple. If you use we use gzip, right, to compress it. What we can just do is to use gun zip to decompress it. What I mean is, remember when we wanted to compress, we just use gzip. So like when we wanted to, we use gzip, then this dot sh, and we have dot gz, right? So to uncompress this file, just use g uncompress, right? Like unzip, right? Then you are actually able to unzip it. If you see it, it will be there because we have that before. So if I still remove this, so we still always have we have our, where is it now? See, now it is gone because we have uncompressed it. So we are dealing with just that file, right? To, you see, it's no longer here, right? To compress it, remember, is this gzip to compress it, right? And now that we compress it, we'll see the compressed file here when we list it, right? Which is this zip does this. But once we uncompress it with unzip, right, what do we get? We get, if you check ls again, we get it uncompressed, and you can see it's no longer. So that's the difference. But if you notice, when you compress it, you save a lot of disk space and memory space. And yes, there are times we compress, you have a backup, the backup is taking volume, you want to compress it to reduce the space it takes, right? Then when you need it, you just uncompress it back. So I hope I've covered that. Now let us just quickly move to, I'll just touch one or two things. Then I'm just going to be writing a simple script on for example, you have a script, but whenever you run this script, it actually tells you the health of your system, right? We are going to like see how we can actually now put a script together that is able to tell you the health of your system, right? Then we can actually, if you want to go down, we can actually have nginx installed, install a little app, then make sure that we have some, it generates some error code. Then we also read the file, and we can say that, oh, if this error code happen, do this. Do you get? But what else do I need to go through? We've gone through, like, I just want to touch some key command. We can't actually cover it in 2 hours, to be honest with you. But as you continue to work with it, you now like, oh, so this is what I've learned, this is how to do this is how to do this, right? But Linux is something you keep learning. You learn it on the job, but at least you understand the basis, how it works. So let us now see how we can actually put all this into shell. But before we even put them into shell, right, I want to explain cron job, because you will be doing cron job a lot. Like when you want to schedule a thing, like so you have a script, but you kind of like set it. I don't want to use what set a timer, but you schedule it to run at a particular interval in a particular time. So let me cover that, so that because we use scheduling a lot for scripting, right? So I just want to cover that, to touch that. Then if possible, maybe we can actually look at some services and log. How do you start a service? When you install a service, how do you start a service? How do you check the log of that service, right? Then we'll just write a little script and we'll round up this video. If you have any question, I'll try to cover them in my Linux cheat sheet. But if you have any question, you can just drop on the comments below, and I will be sure to answer that. So for this cron job, I'm going to be bringing up our board again, right? I want us to understand how a cron job actually works, because you will use it a lot. You use it a lot in pipeline if you want to run some schedules, right? You'll find yourself actually using it a lot. So this is actually what you see. Where is my writing pen? Oh no. So this is actually what you see, right? You actually have, in a cron job, you have asterisks, right? Like what we call star. Let me give it space, three space. You actually have 5 stars, 1, 2, 3, 4, 5, and each of these 5 stars, they mean something, right? What do I mean by each of these 5 stars they mean something? Let's start from this one. This one actually means, this first one, right, actually means, this first one actually means the days of the week, right? Days of, this means days of the week, right? In this case, we have a value for it. The value is 0 to 7. Now I know you are going to ask me, days of the week 0 to 7. Yes, that is because most times Sunday usually takes either 0, so if you see 0 meaning it's Sunday, or 7, right? Command 7. So Sunday takes 0, right? Or it takes 7. So it means Monday takes 1, 2, 3, just like that. Then Saturday is 6, Sunday is 7. So we have 0 to 7, right? So that's days of the week. So let me draw an arrow that shows days of the week. Let's do this. So this first one is actually days of the week. Then the second one is actually the months, right? So let me have, this one is the months. And of course we know that when we talk of months, we have the 12 days. So it has, take value from 1 to 12. Of course this one is easy. January is 1, right? Why December is 12. So what I simply mean is that, let me see, can this give me breakpoint? Yeah, then come on, give me breakpoints. Oh no, okay, yeah, whatever. I thought I can have a break, a line break. Let me see, remove this first. Let's see, can this guy then give me, oh, or should I have a try a free one, which is okay, let's just do this, right? So this will give us something like this, right? Then the third one, let's take our writing again. So the third one, right? So the first one is days of the week. Yeah, and so okay. The third one, right, is actually the days of the month. So days of the month, right? And of course you guess it's going to be from what? It's going to be from 1 to 31, right? Yes, now from 1 to what? 31, right? So we're going to close this. Then the fourth one, so we're going to actually draw this, but let's finish with the fourth one. So the fourth ones, like you guess, right, the fourth one is now going to be the hours, right? HOUR, hours. Of course you know hours is going to be between what? 0 to what? 20 what? 23, And of course, the last but not least is going to be what? Minute. The minutes, right? And the minutes runs from what? You guess it, 0 to what? 50 what? 9. Very good. Mapping, we are following. So let's do this. Let's just, where's our free drawing? Where's our free? Yeah, hands free. So we have this for the third one. No, I think we should clean this and write it. So we're wasting a lot of time. Oh yeah, let's go. So where's our hands free again? Hands free, where are you? Okay, so we have this for the third one, we have this for the fourth one, and we have this for the fifth one. So that's actually how you I run. So if you set a cron job, right? If you set a cron job and you put star star and you put star 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 star, you are simply saying I want you to run every minute of every hour of every day of every month of every year. I hope you understand what I mean. Like run, just keep running this thing continuously, right? Which you don't want to do. But if you have a cron job like this, what if you have something like you set this one to 0 and you set this one to 2, right? What does it mean? It simply means that when you have then star star star, what it simply means is that I want you to run this, whatever it is you want to run. I want you to run, remember, minute is 0, right? But hour is 2, meaning what? We want it to run 2 a.m., right? I want you to run 2 a.m. every day. So this one means what? It will run what? 2 a.m. every day. Do you understand? So this is going to run 2 a.m. every single day. But there are sometimes that you want it to run, instead of you want it to run 2 a.m., right? But maybe only on Fridays, right? Then what do you think you are going to alter? You are just going to alter, you are going to, yes, it's still going to be 2 a.m., but remember this guy determines the week, right? So we are going to have like this. So we are still going to have, oh, sorry, every single day. So what we are going to have is 0 2, right? 0 2, right? Star star. Then of course we say we want it what? Just everyone every Friday. And the Friday will now be, if Sunday is 0, Monday 1, Tuesday 2, Wednesday 3, Thursday 4, Friday is going to be 5. So we are going to have something like this. So that's actually, then if you want it to run on a particular month, then you know the want to alter, right? So this is actually how you see this cron job. This is actually how we set it to work. So this one is going to run every Friday at 2 a.m. Why do we need to run cron job? There are sometimes just want to run backup at every 2 a.m., at every 5 a.m. You set it. You want to run the backup at every 5 a.m. every Friday when the work is done or whatever. You set it. You want to do this particular thing on air. That's, instead of you to keep logging into server to repeat that task, you can actually set a cron job and it's actually able to do that for you. So now that I believe you understand this, now let us go to, we are going to go to the terminal. We're just going to write a little script, right? It can be a little backup script, right? But we are going to set it, and I will show you how you actually set a cron job. We are going to set it to run as a cron job, right? And we're going to see that it's going to run at this interval. How do you start a cron job? How do you stop a cron job? So that's what we're going to be doing with a little script. So to run a SQL cron job, I'm going to go back to our terminal, and we are actually going to be creating a very simple script, right? So let's create we'll call it a cron script, right? Let's just say remember touch, remember touch, right? We are going to say touch cron, right? Let's just use cron.sh, right? So we've created this. If you check now, the file is there, but we want to edit this file. Remember I told you we can actually use what? Nano, then you open the cron job, and we have this. Now we just want to write a very simple batch script here. A very simple and basic batch script is what we want to write here. So now what do we want to write on this script? Remember I told you for you to start a script, remember pound sign, right? The shebang, right? So hash then what? Slash bin and what? Bash, right? So this will make it a bash script. Then we just want to write very small thing inside this script. So for this one, right, we just want to write echo something very simple in a directory that we can see. I just want to show how we set up a cron job. We can actually see that it works. So we're going to do something like this. Remember I say when you say echo, it's going to print out something, right? And we're going to wrap it in a string. So what we want it to print out, we just want it to say that cron, right? Let's do something like cron run at, so that we know the time it runs. I'm going to be using this inbuilt variable, right? And I will explain to us later if we go deeper. So let's do cron run at, right? Let's do something like this. Then we use the inbuilt variable. Remember I talked a little about variable before, but we're going to be using an inbuilt variable that is already in system, which is the system time, right? So I'm just going to be putting date. That's what we're going to use. Then we're going to be closing this. Now we want that when this script runs, right, we should append it to that. We should write the script to a file. And where do we want that file to be? I want it to be in my home directory. So I'm going to be doing something like I want it to be in home. Then that's actually my username that I've been using. Then I want it to be in cron. It's going to create this tsv file .txt, right? So if we do this right, we are going to go to get techie. We'll see something called cron.txt, and it's going to tell us that cron run at is going to tell us the time that it runs, right? So remember, just to exit, Control X, right? Y to say yes, and press enter. So now we have saved this, right? The next thing is we have to remember when you create a script, if you don't make the script as executable, because if we list the script, if it's not executable, we can't really run the script. And because we can't even run it, we can't make cron to run it. Where's our cron script? If you check our cron script, it's not executable. So let's just make this script executable. How do we do that? Remember, do this, right? Then we're just going to do +s. We're going to just give all permission from now. Then what is the name of the script? You know the name of the script, right? Cron, right? So when you do this, now we have made that script executable. Now you can see that that script has that executable permission, and therefore it's ready to run, right? You can see now he's ready to run. So the next thing I want us to do is that we are going to be opening what we call a Chrome tab. So let me clear my screen. We are going to be opening what we call a Chrome tab, right? So we call it cron tab. This is actually where it's like you schedule a job on this system, but later I'll also show you how you can actually automate this entire process. It might not be in this video, it might be a follow-up advanced video on Linux whereby we'll do this one. So you are going to do cron tab, but you are going to say -e. That's we want to edit the cron tab. So when you do this, if you are using it for the first time, to ask you which text editor do you want to use. But right now I'm actually using a nano text editor for this cron tab. So in this cron tab, it's going to tell you edit this file to introduce tasks that you want to run, right? So I'm just going to go and we're going to actually edit this, right? So I'm just going to what I want, I'm just going to put here, right? So it's simple. See what I want. For us to just quickly see this, I'm going to run this, like I want to run this test every minute, right? So I'm going to do something like this. I'm going to do, right, 1 2 3 4. Remember what I told you, that if I run a cron job like this, right, it's going to run like every minute of every day, right? So if I do something like this, now what do I want to run? Which part is my file? Remember my file, that's the cron script I wrote. It's actually in my home, right? It's in my get techie, if you remember. It's in my get techie and is in what we call I call it cron.sh, right? So it means that at every time it's going to be running this script, right? That's actually what it does, right? It's going to run this script every minute. So let's just give it a try, right? So we are going to what? Control X, Y, enter, right? So now that we have this cron job listed, we'll wait for 1 minute and we'll see if it actually runs, right? Another thing, we can list the cron job we have on the system. We can just use cron tab, right? But instead of edit, we can just do flag L to see what we have. And you can see we actually have this cron job. Can you see? So that being said, now we are going to check our directory and see if there's anything called cron.txt, and you can see there's actually a file cron.txt. We never created this. Remember, for us to see what is on code.txt, we can just look at and we'll do what cron.txt in our own case, right? And we can see cron ran at what 7th of April at this time. Can we see? So we can actually see, if you notice, the time is going to be changing every 1 minute anyway. And remember, we say if we also want to do this, right, we actually want to do, remember, we want to do less, but also do what, run a flag F, so that as it's coming we are actually able to see it. So the last time it ran was um what minute was that? Run at Tuesday 7th of April by 1:27. So we should actually be able to see. Oh no, it's not, we didn't run. Let me do, hold on, let's leave here. We want to be able to tail this, not less, sorry, want to be able to tail, right? Then cron.txt, right? So let's see. So we can now, you can see as it's writing every 1 minute. Can you see, first it's run at 1:27, then 1:28. We're going to be waiting for it to run at 1:29. So this is when you know your cron job is working, right? It's actually running every minute, and this is what we want it to do. But imagine on your script, can you see 1:29? But imagine on your script, right? You've put the script together to do something better, like do a backup, do a cleanup. So this is actually how it will run. I just did this every minute for you to actually understand how it works, right? So we are going to be exiting this, right? And we are going to be writing a more reasonable script, right? Okay, so one last thing we can just quickly do, like I said, if you're interested in learning more advanced stuff, can comment below and I'll sure create a follow-up video whereby we're actually automating a whole process on Linux, right? But I'm just going to, based on the command we've used before, we're just going to create a simple script, right? We'll call it systemmetrics.sh, right? Remember again, right? Touch, let's call it systemmetrics.sh, right? So remember, when you create a shell script, if you don't make it executable, you cannot really execute it, right? So this is what we're going to be doing. I'm going to nano, right, systemmetrics.sh, and we're going to be opening it up. So I'm just going to quickly grab a little shell script I've written somewhere before, just for time's sake, right? I'm going to paste it and I'm going to explain to you what each of the line does. It's very simple. We are just echoing. First is the shebang, so we are echoing into our file directory get techie, as in getting me. So we're echoing, but look at the main, this is the main point I want you to notice. This one I'm just running echoing, and this I'm echoing into this, right? That's what it's going to be doing. But see, I'm echoing the time, that's the time, of course it ran. But then I'm appending to this log, right? I'm actually appending to this log. But see, I'm checking the uptime and load. I want to check the uptime of this system, right? I'm also saying this is the uptime. But look at the command I'm running. I'm running uptime. Remember we talked about uptime, how long the system has been up. I'm also running memory usage. How do I check memory usage? Remember I told you free. Then the next one I'm also checking is the CPU, the disk usage, right? You can see. So it's just going to echo the disk usage, the memory usage, and also the uptime. I just want us to just grab these three metrics so that we can actually see it where we run our Chrome job. So we are going to save this script now, right? Then when we save this script, remember Control X, Y, yes, then enter, right? So when we save this script, remember if you check the other Chrome job, we have to go and remove it if we don't want it running again. Because if you check that if you check, you can see it's actually running every minute, and to keep running like this. Do you understand? And if you check process, you actually see that this cron job is running, right? So we can go and either add this one to that chrome table, right? We add this our script, right, to the cron table and tell it to run at a particular time. In this case I want it to run at, let me say, 7 a.m, right? But remember, for us to make our script executable, what do? We do what, right? We change the permission to we change the permission to be executable of what, the system .sh file, right? So now that we've changed the system, we are just going to make sure that this system matrix is what we add to the table. Remember, we do what, cron tab -e to edit. Then we come back here, right? We scroll down to where we have anyone. We have this one running here before, right? So we're just going to change this one. Like I said, I would love it to run, let me say, every 8 a.m, but for you to actually see what it will print now, because we can't wait till 8 a.m, but for you to actually see what it will print, so we're just going to change this one to our system matrix, right? So it's system matrix, right, .sh, and it's going to run every minute for now, right? Then Control S, Y, enter, right? So we will be having this, no, we say so we have this new cron tab now. And now if you check, if it's up to 1 minute, if you check, we actually have system matrix log, because that's where we say you should write the file to. And remember, if we'll tell and watch what is in what system matrix.log, right? System matrix dot, so our own is system matrix, right, dot log. If we trail it, you can see it's actually writing to it, so you can see the log file. It tells us, oh, this is our file system, these are memory use, this is what is available, right? It tells us the file system, it tells us the disk usage, it tells us which other one are we checking for again. So you can actually see it actually writing those log here. If you wait after 1 minute again, it's going to right to this file, right? It's going to see showing us our disk, right? You see it's actually writing the logs to this file. So you can actually do more with this. This is just like example. You can see it's written to the file again. So it kept writing because we are running every minute, but you shouldn't run this kind of file every minute anyway. It does not make sense. So you can run it maybe once in the morning for you to make sure that everything is fine before you start your work for the day, right? So something like that is what we use it for. So that being said, how can we stop the cron job? I'm just going to go to the edit tab and as well remove it again. You get what I mean? So go to edit tab, go to our cron where it is. It's just matter of commenting it out if you want to stop it temporarily. Once you put the pound sign, it's a comment, you comment it out, then Control S, Y, enter, and it will actually stop running. So I hope you get the detail of what we are trying to do on Linux. There's much. I will also be putting the cheat sheet in case you want to go through it, but this is just like basic command, but later we can actually form them into well robust scripts that actually does most of the automation we do. But you can see with just this little you can actually do a lot of debugging and all. So thank you very much for staying this long with me. I hope you have a detailed understanding. If you enjoy it, just tell me, oh, I love this. If you want a complex follow-up script, not complex but a production grade script also, I can actually make a follow-up to solve that issue. Please like and subscribe to this channel. Thank you very much. Bye.